This is a podcast from the archives of the BBC Reith Lectures. This lecture in the series Minds, Brains and Science, given by John Searle, was originally broadcast in 1984.
For thousands of years, people have been trying to understand their relationship to the rest of the universe. For a variety of reasons, many philosophers today are reluctant to tackle such big problems. Nonetheless, the problems remain, and in these lectures I'm going to attack some of them. At the moment, the biggest problem is this. We have a certain common-sense picture of ourselves as human beings, which is very hard to square with our overall scientific conception of the physical world. We think of ourselves as conscious, free, mindful, rational agents in a world that science tells us consists entirely of mindless, meaningless physical particles. Now, how can we square these two conceptions? How, for example, can it be both the case that the world contains nothing but unconscious physical particles, and yet it also contains consciousness? How can a mechanical universe contain intentionalistic human beings that can represent the world to themselves? How can an essentially meaningless world contain meanings? Such problems also spill over into other more contemporary-sounding issues. How shall we interpret recent work in computer science and artificial intelligence, work aimed at making intelligent machines? Specifically, does the digital computer at last give us the right picture of the human mind? And why is it that the social sciences in general have not given us insights into ourselves comparable to those that the natural sciences have given us into the rest of nature? In this first lecture, I want to plunge right into what many philosophers think of as the hardest problem of all. What's the relation of our minds to the rest of the universe? This, I'm sure you'll recognize, is the traditional mind-body or mind-brain problem. In its contemporary version, it usually takes the form, how does the mind relate to the brain? I believe that the mind-body problem has a rather simple solution. One that's consistent both with what we know about neurophysiology and with our common-sense conception of the nature of our mental states, pains, beliefs, desires, and so on. But before presenting that solution, I want to ask, why does the mind-body problem seem so intractable? Why do we still have in philosophy and psychology, after all these centuries, a mind-body problem in a way that we do not have, say, a digestion-stomach problem? Why does the mind seem more mysterious to us than other biological phenomena? I'm convinced that part of the difficulty is that we persist in talking about a 20th century problem in an outmoded 17th century vocabulary. When I was an undergraduate, I remember being dissatisfied with the choices that were apparently available in the philosophy of mind. You could be either a monist or a dualist. If you were a monist, you could be either a materialist or an idealist. If a materialist, you could be either a behaviorist or a physicalist, and so on. One of my aims in what follows is to try to break out of these tired categories. But vocabulary apart, there is still a problem or family of problems. Since Descartes, the mind-body problem has taken the following form. How can we account for the relationships between two apparently completely different kinds of things? On the one hand, there are mental things, such as our thoughts and feelings, and we think of them as subjective, conscious, and immaterial. On the other hand, there are physical things, and we think of them as having mass as extended in space and as causally interacting with other physical things. Most attempted solutions to the mind-body problem wind up by denying the existence of, or in some way downgrading the status of, one or the other of these types of things. Given the successes of the physical sciences, it's not surprising that in our stage of intellectual development, the temptation is to downgrade the status of mental entities. Most of the recently fashionable materialist conceptions of the mind, such as behaviorism, functionalism, and physicalism, end up by denying, implicitly or explicitly, that there are any such things as minds as we ordinarily think of them. That is, they deny that we really do intrinsically have subjective, conscious mental states that are as real as anything else in the universe. Now, why do they do that? Why is it that so many theorists end up by denying the intrinsically mental character of mental phenomena? If we can answer that question, I believe that we will understand why the mind-body problem has seemed so intractable for so long. There are four features of mental phenomena which have made them seem impossible to fit into our scientific conception of the world as made up of material things. It is these four features that have made the mind-body problem really difficult. The first and most important of these features is consciousness. I, at the moment of saying this, and you at the moment of hearing it, are both conscious. It's just a plain fact about the world that it contains such conscious mental states and events, but it's hard to see how mere physical systems could have consciousness. How could such a thing occur? How, for example, could this gray and white gook inside my skull be conscious? I think the existence of consciousness ought to seem amazing to us. Consciousness is the central fact of specifically human existence, because without it, all of the other specifically human aspects of our existence, such as language, love, humor, and so on, would be impossible. I believe it is, by the way, something of a scandal that contemporary discussions in philosophy and psychology have so little of interest to tell us about consciousness. The second intractable feature of the mind is what philosophers and psychologists call intentionality, the feature by which our mental states are directed at, or about, or refer to, or are of objects and states of affairs in the world other than themselves. Intentionality, by the way, doesn't just refer to intentions, but also to beliefs, desires, hopes, fears, love, hate, lust, disgust, shame, pride, irritation, amusement, and all of those mental states, whether conscious or unconscious, that refer to or are about the world apart from the mind. Now, the question about intentionality is much like the question about consciousness. How can this stuff inside my head be about anything? How can it refer to anything? After all, the stuff in the skull consists of atoms in the void, just as all the rest of material reality consists of atoms in the void. How, to put it crudely, can atoms in the void represent anything? The third feature of the mind that seems difficult to accommodate within a scientific conception of reality is the subjectivity of mental states. This subjectivity is marked by such facts as that I can feel my pains and you can't. I see the world from my point of view, you see it from your point of view. I'm aware of myself and my internal mental states as quite distinct from the selves and mental states of other people. Since the 17th century, we've come to think of reality as something which must be equally accessible to all competent observers. That is, we think it must be objective. Now, how are we to accommodate the reality of subjective mental phenomena with the scientific conception of reality as totally objective? Finally, there's a fourth problem, the problem of mental causation. We all suppose, as part of common sense, that our thoughts and feelings make a difference to the way we behave, that they actually have some causal effect on the physical world. I decide, for example, to raise my arm, and, lo and behold, my arm goes up. But if our thoughts and feelings are truly mental, how can they affect anything physical? Are we supposed to think that our thoughts and feelings can somehow produce chemical effects on our brains and the rest of our nervous system? Do we suppose that the thought can wrap itself around the axons and the dendrites, or that it can sneak inside the cell wall and attack the cell nucleus? How could such things possibly occur? But unless some such connection takes place between the mind and the brain, aren't we left with a view that the mind doesn't matter, that it is as unimportant causally as the froth on the wave is to the movement of the wave? If the froth were conscious, it might think to itself, what a tough job it is pulling these waves up on the beach and then pulling them out again all day long. But we know that the froth doesn't make any important difference. Now, why do we suppose our mental life is any more important than a froth on the wave of physical reality? These four features, then, consciousness, intentionality, subjectivity, and mental causation, are what make the mind-body problem seem so difficult. Yet I wish to say they're all real features of our mental lives. Not every mental state has all of them, but any satisfactory account of the mind and of mind-body relations must take account of all four features. If your theory ends up by denying any one of them, you know you must have made a mistake somewhere. The first thesis I want to advance toward solving the mind-body problem is this: mental phenomena, all mental phenomena, whether conscious or unconscious, visual or auditory, pains, tickles, itches, thoughts, indeed all of our mental life, are caused by processes going on in the brain. For example, let's consider pains. Of course, anything we say now may seem wonderfully quaint in a generation or so as our knowledge of how the brain works increases. Nonetheless, the form of the explanation can remain valid, even though the details are altered. On current views, pain signals are transmitted from sensory nerve endings to the spinal cord by at least two types of fibers: delta A fibers, which are specialized for prickling sensations, and C fibers, which are specialized for burning and aching sensations. As the signals go up the spine, they enter the brain by two separate pathways: the prickling pain pathway and the burning pain pathway. Both pathways go through the thalamus, but the prickling pain pathway is more localized afterwards in the somatosensory cortex, whereas the burning pain pathway transmits signals not only upwards into the cortex, but also laterally into the hypothalamus and other regions at the base of the brain. Now, for the purposes of this discussion, the point we need to hammer home is this: our sensations of pains are caused by a series of events that begin at free nerve endings and end in the thalamus and in other regions of the brain. And indeed, as far as the actual sensations are concerned, the events inside the central nervous system are quite sufficient to cause pains, as we know both from the phantom limb pains felt by amputees and the pains caused by artificially stimulating relevant portions of the brain. And I want to suggest that what is true of pain is true of mental phenomena generally. To put it crudely, and counting all of the central nervous system as part of the brain for our present discussion, everything that matters for our mental life, all of our thoughts and feelings, are caused by processes inside the brain. The crucial step is the one that goes on inside the head, not the external or peripheral stimulus. And the argument for this is simple. If the events outside the central nervous system occurred, but nothing happened in the brain, there would be no mental events. But if the right things happened in the brain, the mental events would occur, even if there was no outside stimulus. But if pains and other mental phenomena are caused by processes in the brain, one wants to know, well, what are pains? What are they really? In the case of pains, the obvious answer is that they are unpleasant sorts of sensations. But that answer leaves us unsatisfied because it doesn't tell us how pains fit into our overall conception of the world. Once again, I think the answer to the question is obvious, but it will take some spelling out. To our first claim, pains and other mental phenomena are caused by brain processes, we need to add a second claim. Pains and other mental phenomena are features of the brain and perhaps the rest of the central nervous system. Now, one of the primary aims of this lecture is to show how both of these propositions can be true together. How can it be both the case that brains cause minds, and yet minds just are features of brains? If mental and physical phenomena have cause and effect relationships, how can one be a feature of the other? Wouldn't that imply that the mind caused itself? The dreaded doctrine of causa sui. But at the bottom of our puzzlement is a misunderstanding of causation. It's tempting to think that whenever A causes B, there must be two discrete events, one identified as the cause, the other identified as the effect. That all causation functions in the same way as billiard balls hitting each other. This crude model of the causal relationships between the brain and the mind inclines us to accept some kind of dualism, that events in one material realm, the physical, cause events in another insubstantial realm, the mental. But that seems to me a mistake. And the way to remove the mistake is to get a more sophisticated concept of causation. To do this, I want to turn away from the relationships between mind and brain for a moment to observe some other sorts of causal relationships in nature. A common distinction in physics is between micro and macro properties of systems, the small and large scales. Consider, for example, the desk at which I'm now sitting or the glass of water in front of me. Each object is composed of microparticles. The microparticles have features at the level of molecules and atoms as well as at the deeper level of subatomic particles. But each object also has certain properties such as the solidity of the table, the liquidity of the water, and the transparency of the glass, which are surface or global properties of the physical systems. Many such surface or global properties can be causally explained by the behavior of elements at the micro level. For example, the solidity of the table in front of me is explained by the lattice structure occupied by the molecules of which the table is composed. Similarly, the liquidity of the water is explained by the nature of the interactions between the H2O molecules. Now, it seems to me that these rather banal examples provide a perfectly ordinary model for explaining the puzzling relationships between the mind and the brain. In the case of liquidity, solidity, and transparency, we have no difficulty at all in saying that the surface features are caused by the behavior of elements at the micro level. At the same time, we accept that the surface phenomena just are features of the systems in question. The clearest way I know of stating this point is to say that the surface feature is caused by the behavior of microelements and at the same time is realized in the system that's made up of the microelements. There is indeed a cause and effect relationship, but at the same time the surface features are just higher level features of the very system whose behavior at the micro level causes them. Now, in objecting to this, one might say that liquidity, solidity, and so on are really identical with features of the microstructure. So, for example, we might just define solidity as the lattice structure of the molecular arrangement. Well, this point seems to me correct, but not really an objection to the analysis that I'm proposing. It's a characteristic of the progress of science that an expression that's originally defined in terms of surface features, features accessible to the senses, is subsequently defined in terms of the microstructure that causes the surface features. Thus, to take the example of solidity, the table in front of me is solid in the ordinary sense that it's rigid, it resists pressure, it supports books, it's not easily penetrable by most other objects such as other tables, and so on. Such is the common sense notion of solidity. And in a scientific vein, one can then define solidity as whatever microstructure causes these gross observable features. One can then say either that solidity just is the lattice structure of the system of molecules, and that solidity so defined causes, for example, resistance to touch and pressure. Or one can say that solidity consists of such higher-level things as rigidity and resistance to touch and pressure, and is caused by the behavior of elements at the micro level. Now, if we apply these lessons to the study of the mind, it seems to me there's no difficulty in accounting for the relations of the mind to the brain in terms of the brain's functioning to cause mental states. Just as the liquidity of the water is caused by the behavior of elements at the micro level, and yet at the same time is a feature realized in the system of microelements, so in exactly that sense of caused by and realized in, mental phenomena are caused by processes going on in the brain at the neuronal or modular level, and they are realized in the very system that consists of neurons. And just as we need the micro-macro distinction for any physical system, for the same reasons, we need the micro-macro distinction for the brain. Though we can say of a system of particles that it's 10 degrees centigrade or solid or liquid, we can't say of any given particle that this particle is solid, this particle is liquid, this particle is 10 degrees centigrade. I can't reach into this glass, pull out a molecule, and say this one's wet. Now, in exactly the same way, as far as we know anything at all about it, though we can say of a particular brain, this brain is conscious, or this brain is experiencing thirst or pain, we cannot say of any particular neuron, this neuron is in pain, this neuron is experiencing thirst. To repeat this point, though there are enormous empirical mysteries about how the brain works in detail, there are no logical or philosophical or metaphysical obstacles to accounting for the relation between the mind and the brain in terms that are completely familiar to us from the rest of nature. Well, let's now return to the four problems that seem to face any attempt to solve the mind-brain problem. First, how is consciousness possible? The best way to show how something is possible is to show how it actually exists. We've already given a sketch of how pains are actually caused by neurophysiological processes going on in the thalamus and the sensory cortex. Why is it then that many people feel dissatisfied with this sort of an answer? I think that by pursuing an analogy with an earlier problem in the history of science, we can dispel this sense of puzzlement. For a long time, many biologists and philosophers thought it was impossible, in principle, to account for the existence of life on purely biological grounds. They thought that in addition to the biological processes, some other element must be necessary. Some élan vital must be postulated in order to lend life to what was otherwise just dead and inert matter. It's hard today to realize how intense the dispute was between vitalists and mechanists even a generation ago. But today these issues are no longer taken seriously. Why not? I think it's not so much because mechanism won and vitalism lost, but because we've come to understand better the biological character of the processes that are characteristic of living organisms. Once we understand how the features have a biological explanation, it no longer seems mysterious to us that matter should be alive. And I suggest that exactly similar considerations should apply to our discussions of consciousness. It should seem no more mysterious in principle that this hunk of matter, this gray and white oatmeal-textured substance of the brain, should be conscious, than it seems to us mysterious that this other hunk of matter, this collection of nucleoprotein molecules stuck onto a calcium frame, should be alive. The way, in short, to dispel the mystery is to understand the processes. We don't yet fully understand the processes, but we do understand their general character. We understand that there are certain specific electrochemical activities going on among neurons or neuron modules and perhaps other features of the brain, and that these processes cause consciousness. Our second problem: how can atoms in the void have intentionality? How can they be about something? As with our first question, the best way to show how something is possible is to show how it actually exists. Consider thirst. As far as we know anything about it, at least certain kinds of thirst are caused in the hypothalamus by sequences of nerve firings. These firings are in turn caused by the action of angiotensin in the hypothalamus, and angiotensin in turn is synthesized by renin, which is secreted by the kidneys. Thirst, at least of these kinds, is caused by a series of events in the central nervous system, principally the hypothalamus, and is realized in the hypothalamus. Now, to be thirsty is to have, among other things, the desire to drink. Thirst is therefore an intentional state. It has content, its content determines under what conditions it's satisfied, and it has all the rest of the features that are common to intentional states. As with the mysteries of life and consciousness, the way to master the mystery of intentionality is to describe in as much detail as we can how the phenomena are caused by biological processes while being at the same time realized in biological systems. Visual and auditory experiences, tactile sensations, hunger, thirst, and sexual desire are all caused by brain processes and realized in the structure of the brain, and they are all intentional phenomena. Third, how do we accommodate the subjectivity of mental states within an objective conception of the real world? It seems to me a mistake to suppose that the definition of reality should exclude subjectivity. If a scientific account of the world attempts to describe how things are, then one of the features of the account will be the subjectivity of mental states, since it is just a plain fact about biological evolution that it has produced certain sorts of biological systems, namely human and certain animal brains, that have subjective features. My present state of consciousness is a feature of my brain, but its conscious aspects are accessible to me in a way that they are not accessible to you. And your present state of consciousness is a feature of your brain, and its conscious aspects are accessible to you in a way that they are not accessible to me. Thus, the existence of subjectivity is an objective fact of biology. It's a persistent mistake to try to define science in terms of certain features of existing scientific theories. But once this provincialism is perceived to be the prejudice it is, then any domain of facts is a subject of systematic investigation. If, for example, God existed, then that fact would be a fact like any other. I don't know whether God exists, but I have no doubt at all that subjective mental states exist, because I'm now in one, and so are you. If the fact of subjectivity runs counter to a certain definition of the word science, then it's the definition and not the fact that we will have to abandon. Fourth, the problem of mental causation, for our present purpose, is to explain how mental events can cause physical events. How, for example, could anything as weightless, as gaseous, as ethereal, as a thought give rise to an action? Well, the answer is that thoughts are not weightless, gaseous, and ethereal. When you have a thought, brain activity is actually going on. Brain activity causes bodily movements by physiological processes. Now, because the mental states are features of the brain, they have two levels of description, a higher level in mental terms and a lower level in physiological terms. The very same causal powers of the system can be described at either level. Once again, we can use an analogy from physics to illustrate these relationships. Consider hammering a nail with a hammer. Both hammer and nail have a certain kind of solidity. Hammers made of cotton wool or butter will be quite useless, and hammers made of water or steam are not hammers at all. Solidity is a real causal property of the hammer. But the solidity itself is caused by the behavior of particles at the micro level and is realized in the system of microelements. The existence of two causally real levels of description in the brain is exactly analogous to the existence of two causally real levels of description of the hammer. Consciousness, for example, is a real property of the brain that can cause things to happen. My conscious attempt to perform an action such as raising my arm causes the movement of the arm. At the higher level of description, the intention to raise my arm causes the movement of the arm. At the lower level of description, a series of neuron firings starts a chain of events that results in the contraction of the muscles. As with the case of hammering a nail, the same sequence of events has two levels of description. Both of them are causally real, and the higher level causal features are both caused by and realized in the structure of the lower level elements. To summarize, on my view, the mind and the body interact, but they're not two different things, since mental phenomena are features of the brain. One way to characterize this solution to the mind-body problem is to see it as an assertion of both physicalism and mentalism. Suppose we define naive physicalism to be the view that all that exists in the world are physical particles with their properties and relations. The power of the physical model of reality is so great that it's hard to see how we can seriously challenge naive physicalism. And now let's define naive mentalism to be the view that mental phenomena really exist. There really are mental states. Some of them are conscious, many have intentionality, they all have subjectivity, and many of them function causally in determining physical events in the world. The thesis of this first Reith lecture can now be stated quite simply. Naive mentalism and naive physicalism are perfectly consistent with each other. Indeed, as far as we know anything about how the world works, they're not only consistent, they're both true.
This is a podcast from the archives of the BBC Reith Lectures. This lecture in the series Minds, Brains and Science, given by John Searle, was originally broadcast in 1984.
In my last lecture, I provided at least the outlines of a solution to the so-called mind-body problem. Mental processes are caused by the behavior of elements of the brain. At the same time, they are realized in the structure that's made up of those elements. Now, I think this answer is consistent with standard biological approaches to biological phenomena. However, it's very much a minority point of view. The prevailing view in philosophy, psychology, and artificial intelligence is one which emphasizes the analogies between the functioning of the human brain and the functioning of digital computers. According to the most extreme version of this view, the brain is just a digital computer and the mind is just a computer program. One might summarize this view, I call it strong artificial intelligence or strong AI, by saying that the mind is to the brain as the program is to the computer hardware. This view has the consequence that there's nothing essentially biological about the human mind. The brain just happens to be one of an indefinitely large number of different kinds of hardware computers that could sustain the programs which make up human intelligence. On this view, any physical system whatever that had the right program with the right inputs and outputs would have a mind in exactly the same sense that you and I have minds. So, for example, if you made a computer out of old beer cans powered by windmills, if it had the right program, it would have to have a mind. And the point is not that for all we know it might have thoughts and feelings, but rather it must have thoughts and feelings, because that's all there is to having thoughts and feelings, implementing the right program. Now, most people who hold this view think we have not yet designed programs which are minds. But there's pretty much general agreement among them that it's only a matter of time until computer scientists and workers in artificial intelligence design the appropriate hardware and programs which will be the equivalent of human brains and minds. Many people outside the field of artificial intelligence are quite amazed to discover that anybody could believe such a view as this. So before criticizing it, let me give you a few examples of the things that people in this field have actually said. Herbert Simon of Carnegie Mellon University says that we already have machines that can literally think. Well, fancy that. Philosophers have been worried for centuries about whether or not a machine could think, and now we discover that they've already got such machines at Carnegie Mellon. Simon's colleague Alan Newell claims that we have now discovered, and notice that Newell says discovered and not just hypothesized or considered the possibility, but actually discovered that intelligence is just a matter of physical symbol manipulation. It has no essential connection with any kind of biological or physical wetware or hardware. Both Simon and Newell, to their credit, emphasize that there's nothing metaphorical about these claims. They mean them quite literally. Marvin Minsky of MIT says that the next generation of computers will be so intelligent that we will be lucky if they're willing to keep us around the house as household pets. But my all-time favorite in the literature of exaggerated claims on behalf of the digital computer is from John McCarthy, the inventor of the term artificial intelligence. McCarthy says, even a machine as simple as a thermostat can be said to have beliefs. And indeed, almost any machine capable of problem-solving can be said to have beliefs. I admire McCarthy's courage. I once asked him, what beliefs does your thermostat have? And he said, my thermostat has 3 beliefs. It believes it's too hot in here, it's too cold in here, and it's just right in here. Now, as a philosopher, I like all these claims for a simple reason. Unlike most philosophical theses, they are reasonably clear, and they can be simply and decisively refuted. It's this refutation that I am going to undertake in this lecture. The nature of the refutation has nothing whatever to do with any particular stage of computer technology. I think it's important to emphasize that because in these discussions, the temptation is always to think that the solution to our problems must wait on some as yet uncreated technological wonder. But in fact, the nature of the refutation is completely independent of any state of technology. It has to do with the very definition of a digital computer, with what a digital computer is. It's essential to our conception of a digital computer that its operations can be specified purely formally. That is, we specify the steps in the operation of the computer in terms of abstract symbols, sequences of zeros and ones printed on a tape, for example. A typical computer rule will determine that when a machine is in a certain state and it has a certain symbol on its tape, then it will perform a certain operation, such as erasing the symbol or printing another symbol, and then enter another state, such as moving the tape one square to the left. But the symbols have no meaning. They have no semantic content. They're not about anything. They have to be specified purely in terms of their formal or syntactical structure. The zeros and ones are just numerals. They don't even stand for numbers. Indeed, it's this feature of digital computers that makes them so powerful. One and the same type of hardware, if it's appropriately designed, can be used to run an indefinite range of different programs, and one and the same program can be run on an indefinite range of different types of hardwares. But this feature of programs, that they're defined purely formally or syntactically, is fatal to the view that mental processes and program processes are identical. And the reason can be stated quite simply. There's more to having a mind than having formal or syntactical processes. Our internal mental states, by definition, have certain sorts of contents. If I'm thinking about Kansas City or wishing that I had a cold beer to drink or wondering if there will be a fall in interest rates, in each case my mental state has a certain mental content in addition to whatever formal features it might have. That is, even if my thoughts occur to me in strings of symbols, there must be more to the thought than the abstract strings, because strings by themselves can't have any meaning. If my thoughts are to be about anything, then the strings must have a meaning which makes the thoughts about those things. In a word, the mind has more than a syntax, it has a semantics. Now, the reason that no computer program can ever be a mind is simply that a computer program is only syntactical, and minds are more than syntactical. Minds are semantical in the sense that they have more than a formal structure. They have a content. Now, to illustrate this point, I've designed a certain thought experiment. Imagine that a bunch of computer programmers have written a program that will enable a computer to simulate the understanding of Chinese. So, for example, if the computer is given a question in Chinese, it will match the question against its memory or database and produce appropriate answers to the question in Chinese. Suppose, for the sake of argument, that the computer's answers are as good as those of a native Chinese speaker. Now then, does the computer, on the basis of this, understand Chinese? Does it literally understand Chinese in the way that Chinese speakers understand Chinese? Well, imagine that you are locked in a room, and that in this room are several baskets full of Chinese symbols. Imagine that you, like me, do not understand a word of Chinese, but that you're given a rule book in English for manipulating these Chinese symbols. The rules specify the manipulations of the symbols purely formally, in terms of their syntax, not their semantics. So a rule might say, take a squiggle sign out of basket number 1 and put it next to a squoggle sign from basket number 2. Now suppose that some other Chinese symbols are passed into the room and that you are given further rules for passing back Chinese symbols out of the room. Suppose that, unknown to you, the symbols passed into the room are called questions by the people outside the room, and the symbols you pass back out of the room are called answers to the questions. Suppose, furthermore, that the programmers are so good at designing the program and that you are so good at manipulating the symbols that very soon your answers are indistinguishable from those of a native Chinese speaker. There you are, locked in your room, shuffling your Chinese symbols and passing out Chinese symbols in response to incoming Chinese symbols. On the basis of the situation as I have described it, there's no way you could learn any Chinese simply by manipulating these formal symbols. Now, the point of this whole story is simply this. By virtue of implementing a formal computer program, you behave exactly as if you understood Chinese, but all the same, you don't understand a word of Chinese. But now, if going through the appropriate computer program for understanding Chinese is not enough to give you an understanding of Chinese, then it's not enough to give any other digital computer an understanding of Chinese. And again, the reason for this can be stated quite simply. If you don't understand Chinese, then no other computer could understand Chinese, because no digital computer, just by virtue of running a program, has anything that you don't have. All that the computer has is, as you have, a formal program for manipulating uninterpreted Chinese symbols. To repeat, a computer has a syntax, but no semantics. The whole point of the parable of the Chinese room is to remind us of a fact that we knew all along. Understanding a language, or indeed having mental states at all, involves more than having just formal symbols. It involves having an interpretation or a meaning attached to those symbols. And a digital computer, as defined, cannot have more than just formal symbols, because the operation of the computer, as I said earlier, can only be defined in terms of its ability to implement programs. And these programs are purely formally specifiable. That is, they have no semantic content. I think we can see the force of this argument if we contrast what it's like to be asked and to answer questions in English and to be asked and to answer questions in some language where we have no knowledge of any of the meanings of the words. Imagine that in the Chinese room you're also given questions in English about such things as your age or your life history, and that you answer these questions. Now, what's the difference between the Chinese case and the English case? Well, again, if like me you understand no Chinese and you do understand English, then the difference is obvious. You understand the questions because they're expressed in symbols whose meanings are known to you. Similarly, when you give the answers in English, you're producing symbols which are meaningful to you. But in the case of the Chinese, you have none of that. In the case of the Chinese, you simply manipulate formal symbols according to a computer program, and you attach no meaning to any of the elements. Now, various replies have been suggested to this argument by workers in artificial intelligence and in psychology as well as philosophy. They all have something in common. They are all inadequate. And there's an obvious reason why they have to be inadequate, since the argument rests on a very simple logical truth. Namely, syntax alone is not sufficient for semantics, and digital computers, insofar as they are computers, have, by definition, a syntax alone. I want to make this clear by considering a couple of the arguments that are often presented against me. Some people attempt to answer the Chinese room example by saying that the whole system understands Chinese. The idea here is that though I, the person in the room manipulating the symbols, do not understand Chinese, I'm just the central processing unit of the computer system. And they argue that it's the whole system, including the room, the baskets full of symbols, the ledgers containing the programs, and perhaps other items as well, taken as a totality that understands Chinese. But this is subject to exactly the same objection I made before. There's no way that the system can get from the syntax to the semantics. I, as the central processing unit, have no way of figuring out what any of these symbols means, but then neither does the whole system. Another common response is to imagine that we put the Chinese understanding program inside a robot. If the robot moved around and interacted causally with the world, wouldn't that be enough to guarantee that it understood Chinese? Once again, the inexorability of the semantic-syntax distinction overcomes this maneuver. As long as we suppose that the robot has only got a computer for a brain, then even though it might behave exactly as if it understood Chinese, it would still have no way of getting from the syntax to the semantics of Chinese. You can see this if you imagine, once again, that I am the computer. Inside a room in the robot's skull, I shuffle symbols without knowing that some of them come into me from television cameras attached to the robot's head, and others go out to move the robot's arms and legs. As long as all I have is a formal computer program, I have no way of attaching any meaning to any of the symbols. So suppose the robot picks up a hamburger, and this triggers the symbol for hamburger to come into the room. Well, as long as all I have is the symbol, with no knowledge of its causes or how it got there, I have no way of knowing what it means. The causal interactions between the robot and the rest of the world are irrelevant unless those causal interactions are represented in some mind or other. But there's no way they can be if all that the so-called mind consists of is a set of purely formal, syntactical operations. It's important to see exactly what is claimed and what is not claimed by my argument. Suppose we ask that question that I mentioned at the beginning, could a machine think? Well, in one sense, of course, we're all machines. We can construe the stuff inside our heads as a meat machine. And of course, we can all think. So trivially, there are machines that can think. But that wasn't really the question that bothered us. So let's try a different formulation of it. Could an artifact think? Could a man-made machine think? Well, once again, it depends on the kind of artifact. Suppose we designed a machine that was molecule for molecule indistinguishable from a human being. Well then, if you can duplicate the causes, you can presumably duplicate the effects. So once again, the answer to that question is, in principle at least, trivially, yes. If you could build a machine that had the same structure as a human being, then presumably that machine would be able to think. Indeed, it would be a surrogate human being. Well, let's try again. The question isn't, can a machine think, or can an artifact think? The question is, can a digital computer think? But now, once again, we have to be very careful in how we interpret the question. From a mathematical point of view, anything whatever can be described as if it were a digital computer, and that's because it can be described as instantiating or implementing a computer program. So in an utterly trivial sense, the pen that's on the desk in front of me can be described as a digital computer. It just happens to have a very boring computer program. The program says, stay there. Now, since in this sense, anything whatever is a digital computer because anything whatever can be described as implementing a computer program, then once again our question gets a trivial answer. Of course our brains are digital computers since they implement any number of computer programs, and of course our brains can think. So once again there's a trivial answer to the question, but that wasn't really the question we wanted to ask. The question we wanted to ask is this: can a digital computer as defined think? That is to say, is instantiating or implementing the right computer program with the right inputs and outputs sufficient for or constitutive of thinking? And the answer to this question, unlike its predecessors, is clearly no. And it's no for the reason that we have spelled out, namely, the computer program is defined purely syntactically. But thinking is more than just a matter of manipulating meaningless symbols. It involves meaningful semantic contents. These semantic contents are what we mean by meaning. It's important to emphasize again that we're not talking about a particular stage of computer technology. My argument has nothing to do with the forthcoming amazing advances in computer science. No doubt we will be much better able to simulate human behavior on computers than we can at present, and certainly much better than we have been able to in the past. But the point I am making is that if we're talking about having mental states, having a mind, all of these simulations are simply irrelevant. It doesn't matter how good the technology is or how rapid the calculations made by the computer are. If it's really a computer, its operations have to be defined syntactically, whereas consciousness, thoughts, feelings, emotions, and all the rest of it involve more than a syntax. Those features, by definition, the computer is unable to duplicate, however powerful may be its ability to simulate. The key distinction here is between duplication and simulation, and no simulation by itself ever constitutes duplication. What I've done so far is to give a basis to the sense that those quotations I began this talk with are really as preposterous as they seem. But there's a puzzling question in this discussion, and that is, Why would anybody ever have thought that computers could think or have feelings and emotions and all the rest of it? After all, we can do computer simulations of any process at all that can be given a formal description. So we can do a computer simulation of the flow of money in the British economy or the pattern of power distribution in the Labour Party. We can do computer simulations of rainstorms in the home counties or warehouse fires in East London. Now, in each of these cases, nobody supposes that the computer simulation is actually the real thing. No one supposes that a computer simulation of a storm will leave us all wet, or a computer simulation of a fire is likely to burn the house down. Why on earth would anyone in his right mind suppose a computer simulation of mental processes actually had mental processes? I don't really know the answer to that, since the idea seems to me, to put it frankly, quite crazy from the start. But I have a couple of speculations. First of all, where the mind is concerned, a lot of people are still tempted to some sort of behaviorism. They think if a system behaves as if it understood Chinese, then it really must understand Chinese. But we've already refuted this form of behaviorism with the Chinese room argument. Another assumption made by many people is that the mind is not part of the biological world. It's not a part of the world of nature. The strong artificial intelligence view relies on that in its conception that the mind is purely formal, that somehow or other it cannot be treated as a concrete product of biological processes like any other biological product. There is in these discussions, in short, a kind of residual dualism. AI partisans believe that the mind is more than a part of the natural biological world. They believe that the mind is purely formally specifiable. And the paradox of this is that the AI literature is filled with fulminations against some view called dualism. But in fact, the whole thesis of strong AI rests on a kind of dualism. It rests on a rejection of the idea that the mind is just a natural biological phenomenon in the world like any other. I want to conclude this lecture by putting together the thesis of the last lecture and the thesis of this one. Both of these theses can be stated very simply, and indeed I'm going to state them with perhaps excessive crudeness. But if we put them together, I think we get a quite powerful conception of the relations of minds, brains, and computers. And the argument has a very simple logical structure, so you can see whether it's valid or invalid. In fact, you might want to jot down the premises and the conclusions of this argument. The first premise is brains cause minds. Well, of course, that's really too crude. What we mean by that is that mental processes that we consider to constitute a mind are caused, that is, entirely caused, by processes going on inside the brain. But let's be crude. Let's just write that down as 3 words. Brains cause minds, and that's just a fact about how the world works. Now let's write proposition number 2. Syntax is not sufficient for semantics. That proposition is a conceptual truth. It just articulates our distinction between the notion of what is purely formal and what has content. Now, to these 2 propositions, that brains cause minds and that syntax is not sufficient for semantics, let's add a third and a fourth. Third, computer programs are entirely defined by their formal or syntactical structure. That proposition, I take it, is true by definition. It's part of what we mean by the notion of a computer program. Now let's add proposition 4. Minds have mental contents. Specifically, they have semantic contents. And that, I take it, is just an obvious fact about how our minds work. Now, from these 4 premises, we can draw our first conclusion, and it follows obviously from 2, 3, and 4. Namely, this is conclusion 1. No computer program by itself is sufficient to give a system a mind. Programs, in short, are not minds, and they are not by themselves sufficient for having minds. Now, that's a very powerful conclusion because it means that the project of trying to create minds solely by designing programs is doomed from the start. This is a purely formal or logical result from a set of axioms which are agreed to by all, or nearly all, of the disputants concerned. That is, even the most hardcore enthusiast for artificial intelligence agrees that in fact, as a matter of biology, brain processes cause mental states, and they agree that programs are defined purely syntactically. But if you put these conclusions together with certain other things that we know, then it follows immediately that the project of strong AI is incapable of fulfillment. However, once we've got these axioms, let's see what else we can derive. Here's a second conclusion. The way that brain functions cause minds cannot be solely in virtue of running a computer program. And this second conclusion follows from the first premise as well as from our first conclusion. That is, from the fact that brains cause minds and that programs are not enough to do the job, it follows that the way that brains cause minds can't be solely by running a computer program. Now that also, I think, is an important result, because it has the consequence that the brain is not, or at least is not just, a digital computer. We saw earlier that anything can be trivially described as if it were a digital computer, and brains are no exception. But the importance of this conclusion is that the computational properties of the brain are simply not enough to explain its functioning to produce mental states. And indeed, that ought to seem a common-sense scientific conclusion to us anyway, because all it does is remind us of the fact that brains are biological engines. Their biology matters. It's not, as several people in artificial intelligence have claimed, it's not just an irrelevant fact about the mind that it happens to be realized in human brains. Now, from our first premise, we can also derive a third conclusion. Anything else that caused minds would have to have causal powers at least equivalent to those of the brain. And this third conclusion is a trivial consequence of our first premise. It's a bit like saying that if my petrol engine drives my car at 75 miles an hour, then any diesel engine that was capable of doing that would have to have a power output at least equivalent to that of my petrol engine. Of course, some other system might cause mental processes using entirely different chemical or biochemical features from those that the brain in fact uses. It might turn out that there are beings on other planets or in some other solar system that have mental states and yet use an entirely different biochemistry from ours. Suppose that Martians arrived on Earth and we concluded that they had mental states. But suppose that when their heads were opened up, it was discovered that all they had inside was green slime. Well, still, the green slime, if it functioned to produce consciousness and all the rest of their mental life, would have to have causal powers equal to those of the human brain. But now, from our first conclusion that programs are not enough, and our third conclusion that any other system would have to have causal powers equal to the brain, conclusion 4 follows immediately. For any artifact that we might build which had mental states equivalent to human mental states, the implementation of a computer program would not by itself be sufficient. Rather, the artifact would have to have powers equivalent to the powers of the human brain. The upshot of this entire discussion, I believe, is to remind us of something that we've known all along. Namely, mental states are biological phenomena. Consciousness, intentionality, subjectivity, and mental causation are all a part of our biological life history, along with growth, reproduction, the secretion of bile, and digestion.
This is a podcast from the archives of the BBC Reith Lectures. This lecture in the series Minds, Brains and Science, given by John Searle, was originally broadcast in 1984.
We feel perfectly confident in saying things like, Basil voted for the Tories because he liked Mrs. Thatcher's handling of the Falklands affair. But we have no idea how to go about saying things like, Basil voted for the Tories because of a condition of his hypothalamus. That is, We have common sense explanations of people's behavior in mental terms, in terms of their desires, wishes, fears, hopes, and so on. And we suppose that there must also be a neurophysiological sort of explanation of people's behavior in terms of processes in their brains. The trouble is that the first of these sorts of explanation works well enough in practice, but is not scientific, whereas the second is certainly scientific, but we have no idea how to make it work in practice. Now that leaves us apparently with a gap between the brain and the mind. And some of the greatest intellectual efforts of the 20th century have been attempts to fill this gap, to get a science of human behavior which was not just common sense grandmother psychology, but was not scientific neurophysiology either. Up to the present time, without exception, the gap-filling efforts have been failures. Behaviorism was the most spectacular failure, but in my lifetime I have lived through exaggerated claims made on behalf of, and eventually disappointed by, games theory, cybernetics, information theory, structuralism, sociobiology, and a bunch of others. To anticipate a bit, I'm going to claim that all the gap-filling efforts fail because there isn't any gap to fill. The most recent gap-filling efforts rely on analogies between human beings and digital computers. On the most extreme version of this view, which I call strong artificial intelligence, or just strong AI, the brain is a digital computer and the mind is just a computer program. Now that's the view I refuted last week. The latest attempt to fill the gap is often called cognitivism because it derives from work in cognitive psychology and artificial intelligence, and it forms the mainstream of a new discipline of cognitive science. Like strong AI, it sees the computer as the right picture of the mind and not just as a metaphor. But unlike strong AI, it does not, or at least it doesn't have to, claim that computers literally have thoughts and feelings. If one had to summarize the research program of cognitivism, it would look like this. Thinking is processing information, but information processing is just symbol manipulation. Computers do symbol manipulation, so the best way to study thinking, or as they prefer to call it, cognition, is to study computational symbol manipulating programs, whether they are in computers or in brains. On this view, then, the task of cognitive science is to characterize the brain not at the level of nerve cells, nor at the level of conscious mental states, but rather at the level of its functioning as an information processing system, and that's where the gap gets filled. Now, I really can't exaggerate the extent to which this research program has seemed to constitute a major breakthrough in the science of the mind. Indeed, according to its supporters, it might even be the breakthrough that will at last place psychology on a secure scientific footing now that it has freed itself from the delusions of behaviorism. I'm going to attack cognitivism in this lecture, but I want to begin by illustrating its attractiveness. We know that there is a level of naive, common-sense grandmother psychology and also a level of neurophysiology, a level of neurons and neuron modules and synapses and neurotransmitters and boutons and all the rest of it. So why would anyone suppose that between these two levels, there's also a level of mental processes which are computational processes? And indeed, why would anyone suppose that it's at that level that the brain performs those functions that we regard as essential to the survival of the organism, namely the functions of information processing? Well, there are several reasons. First of all, let me mention one which is somewhat disreputable, but I think it's actually quite influential. Because we don't understand the brain very well, we're constantly tempted to use the latest technology as a model for trying to understand it. In my childhood, we were always assured that the brain was a telephone switchboard. What else could it be? And I was amused to see that Sherrington, the great British neuroscientist, thought that the brain worked like a telegraph system. Freud often compared the brain to hydraulic and electromagnetic systems. Leibniz compared it to a mill, and now, obviously, the metaphor is the digital computer. And this, by the way, fits in with the general exaggerated guff that we hear nowadays about computers and robots. We're frequently assured by the popular press that we're on the verge of having household robots that will do all the housework, babysit our children, amuse us with lively conversation, and take care of us in our old age. This, of course, is so much nonsense. We're nowhere near being able to produce robots that can do any of these things. And indeed, successful robots have been confined to very restricted tasks in very limited contexts, such as automobile production lines. Well, let's get back to the serious reasons that people have for supposing that cognitivism is true. First of all, they suppose that they actually have some psychological evidence that it's true. I don't intend to say very much about this evidence because I think everyone would agree that it's quite inconclusive and subject to a lot of different interpretations. However, underlying the computational interpretation of the evidence is a deeper and, I believe, more influential reason for accepting cognitivism. The second reason goes like this. Because we can design computers that follow rules when they process information, and because apparently human beings also follow rules when they think, then there's some unitary sense in which the brain and the computer are functioning in a similar, and indeed maybe the same, fashion. The third assumption that lies behind the cognitive research program is an old one. It goes back as far as Leibniz and probably as far as Plato. It's the assumption that a mental achievement must have theoretical causes. It's the assumption that if the output of a system is meaningful, in the sense that, for example, our ability to learn a language or our ability to recognize faces is a meaningful cognitive ability, then there must be some theory internalized somehow in our brains that underlies this ability. Well, what shall we make of these arguments for cognitivism? I don't believe that I have a knockdown refutation of cognitivism in the way that I do believe I have one for strong AI. But I believe that if we examine the arguments that are given in favor of cognitivism, we will see that they are very weak indeed. And in fact, an exposure of their weaknesses will enable us to understand several important differences between the way human beings behave and the way computers function. Let's start with the notion of rule following. We're told that human beings follow rules and that computers follow rules. But I want to argue that there's a crucial difference. In the case of human beings, whenever we follow a rule, we are being guided by the actual content or the meaning of the rule. In the case of human rule following, meanings cause behavior. Now, of course, they don't cause the behavior all by themselves, but they certainly play a causal role in the production of the behavior. So consider the rule, drive on the left-hand side of the road in Great Britain. Now, whenever I come to Britain, I have to remind myself of this rule. How does it work? To say that I'm obeying the rule is to say that the meaning of that rule, that is, its semantic content, plays some kind of causal role in the production of what I actually do. Notice that there are lots of other rules that would describe what's happening, but they're not the rules that I happen to be following. So, for example, assuming that I'm on a two-lane road and that the steering wheel is located on the right-hand side of the car, then you could say that my behavior is in accord with the rule, drive in such a way that the steering wheel is nearest to the center line of the road. Now, that is, in fact, a correct description of my behavior, but that's not the rule that I follow in Britain. The rule I follow is drive on the left-hand side of the road. I want to make this point completely clear, so let me give you another example. When my children went to the Oakland driving school, they were taught a rule for parking cars. The rule was maneuver your car toward the curb with the steering wheel in the extreme right position until your front wheels are even with the rear wheels of the car in front of you. Then turn the steering wheel all the way to the extreme left position. Now notice that if they're following this rule, then its meaning must play a causal role in the production of their behavior. I was interested to learn this rule because it's not a rule that I follow. In fact, I don't follow a rule at all when I park a car. I just look at the curb and try to get as close to the curb as I can without bashing into the cars in front of and behind me. But notice, it might turn out that my behavior, viewed from outside, viewed externally, is identical with the behavior of the person who's following the rule. The formal properties of the behavior are not sufficient to show that a rule is being followed. In order that the rule be followed, the meaning of the rule has to play some causal role in the behavior. Now, the moral of this discussion for cognitivism can be put very simply. In the sense in which human beings follow rules, and incidentally, human beings follow rules a whole lot less than cognitivists claim they do, but in that sense, computers don't follow rules at all. They only act in accord with certain formal procedures. The program of the computer determines the various steps that the machinery will go through. It determines how one state will be transformed into a subsequent state. And we can speak metaphorically as if this were a matter of following rules. But in the literal sense in which human beings follow rules, computers do not follow rules. They only act as if they were following rules. Now, such metaphors are quite harmless. Indeed, they're both common and useful in science. We can speak metaphorically of any system as if it were following rules, the solar system, for example. The metaphor only becomes harmful if it's confused with the literal sense. It's okay to use a psychological metaphor to explain the computer. The confusion comes when you take the metaphor literally and then try to use the computer to explain the psychology. So we have two senses of rule following, a literal and a metaphorical, and it's very easy to confuse the two. Now, I want to apply the lessons of this example to the notion of information processing. I believe the notion of information processing embodies a similar, massive confusion. The idea is that since I process information when I think, and since my calculating machine processes information when it takes something as input, transforms it, and produces information as output, then there must be some unitary sense in which we are both processing information. But that seems to me obviously false. The sense in which I do information processing when I think is the sense in which I am consciously or unconsciously engaged in certain mental processes. But in that sense of information processing, the calculator doesn't do information processing since it doesn't have any mental processes at all. It simply mimics or simulates the formal features of the mental processes that I have. That is, even if the steps that the calculator goes through are formally the same as the steps that I go through, it wouldn't show that the machine does anything at all like what I do, for the very simple reason that the calculator has no mental phenomena. In adding 6 and 3, it doesn't know that the numeral 6 stands for the number 6, and that the numeral 3 stands for the number 3, and that the plus sign stands for the operation of addition. And that's for the very simple reason that it doesn't know anything. Indeed, that's why we have calculators. They can do calculations faster and more accurately than we can without having to go through any mental effort to do it. In the sense in which we have to go through information processing, they don't. We need then to make a distinction between two senses of the notion of information processing, or at least two radically different kinds of information processing. The first kind, which I will call psychological information processing, involves mental states. To put it at its crudest, when people perform mental operations, they actually think. And thinking characteristically involves processing information of one kind or another. But there's another sense of information processing in which there are no mental states at all. In these cases, there are processes which are as if there were some mental information processing going on. Let's call these second kinds of cases of information processing as if forms of information processing. It's perfectly harmless to use both of these two kinds of mental ascriptions, provided we do not confuse them. However, what we find in cognitivism is a persistent confusion of the two. Now, once we see this distinction clearly, we can see one of the most profound weaknesses in the cognitivist argument. From the fact that I do information processing when I think, and the fact that the computer does information processing, even information processing which may simulate the formal features of my thinking, it simply doesn't follow that there's anything psychologically relevant about the computer program. In order to show psychological relevance, there would have to be some independent argument that the as-if computational information processing is psychologically relevant. The notion of information processing is being used to mask this confusion because one expression is being used to cover two quite distinct phenomena. In short, the confusion that we found about rule following has an exact parallel in the notion of information processing. However, there's a deeper and more subtle confusion involved in this notion of information processing. Notice that in the as-if sense of information processing, any system whatever can be described as if it were doing information processing. And indeed, we might even use it for gathering information. So it isn't just a matter of using calculators and computers. Consider, for example, water running downhill. Now, we can describe the water as if it were doing information processing, and we might even use it to get information. We might use it, for example, to get information about the line of least resistance in the contours of the hill. But it simply doesn't follow from that there's anything of any psychological relevance about water running downhill. There's no psychology at all to the action of gravity on water. But we can apply the lessons of this point to the study of the brain. It's an obvious fact that the brain has a level of real psychological information processes. To repeat, people actually think, and thinking goes on in their brain. Furthermore, there are all sorts of things going on in the brain at the neurophysiological level that actually cause our thought processes. But many people suppose that in addition to these two levels, the level of naive psychology and the level of neurophysiology, there must be some additional level of computational information processing. Now, why do they suppose that? I believe it's because they confuse the psychologically real level of information processing with the possibility of giving as-if information processing descriptions of the processes that are going on in the brain. So if you talk about water rolling downhill, everyone can see that it's psychologically irrelevant. But it's harder to see that exactly the same point applies to the brain. What is psychologically relevant about the brain are the facts that it contains psychological processes and that it has a neurophysiology that causes and realizes those processes. But the fact that we can then describe other processes in the brain from an as-if information processing point of view by itself provides no evidence that these are at all psychologically real or even psychologically relevant. Once we're talking about the inside of the brain, it's harder to see the confusion, but it's exactly the same confusion. The next assumption to examine is the idea that behind all meaningful behavior there must be some internal theory. One finds this assumption in many areas, and not just in cognitive psychology. So, for example, Chomsky's search for a universal grammar is based on the assumption that if there are certain features common to all languages, and if these features are constrained by common features of the human brain, then there must be an entire complex set of rules of universal grammar in the brain. But a much simpler hypothesis would be that the physiological structure of the brain constrains possible grammars without the intervention of an intermediate level of rules or theories. Not only is this hypothesis simpler, but also the very existence of universal features of language constrained by innate features of the brain suggests that the neurophysiological level of description is enough to do the job. You don't need to suppose that there are any rules on top of the neurophysiological structures. A couple of analogies I hope will make this clear. It's a simple fact about human vision that we can't see infrared or ultraviolet. Now, is that because we have a universal rule of visual grammar that says, don't see infrared or ultraviolet? No, it's obviously because our visual apparatus simply is not sensitive to these two ends of the spectrum. Or to take another example, if we try to do a theoretical analysis of the human ability to stay in balance while walking, it might look as if there were some more or less complex mental processes going on. As if taking in cues of various kinds, we solved a series of quadratic equations, unconsciously of course, and these enabled us to walk without falling over. But we actually know that this sort of mental theory is not necessary to account for the achievement of walking without falling over. In fact, it's done in a very large part by fluids in the inner ear that simply do no calculating at all. If you spin around enough so as to upset the fluids, you're likely to fall over. Now, I want to suggest that a great deal of our cognitive achievements may well be like that. The brain just does them. We have no good reason for supposing that in addition to the level of our mental states and the level of our neurophysiology, there is some unconscious calculating going on. Consider face recognition. We all recognize the faces of our friends, relatives, and acquaintances quite effortlessly, and indeed we now have evidence that certain portions of the brain are specialized for face recognition. How does it work? Well, suppose we were going to design a computer that could recognize faces as we do. It would carry out quite a computational task involving a lot of calculating of geometrical and topographical features. But is that any evidence that the way that we do it involves calculating and computing? Notice that when we step in wet sand and make a footprint, neither our feet nor the sand does any computing. But if we were going to design a program that would calculate the topology of a footprint from information about differential pressures on the sand, it would be a fairly complex computational task. The fact that a computational simulation of a natural phenomenon involves complex information processing does not show that the phenomenon itself involves such processing. And it may be that facial recognition is as simple and as automatic as making footprints in the sand. Indeed, if we pursue the computer analogy consistently, we find that there are a great many things going on in the computer that are not computational processes either. For example, in the case of some calculators, if you ask, how does the calculator multiply 7 times 3? The answer is, it adds 3 to itself 7 times. But if you then ask, and how does it add 3 to itself? There isn't any computational answer to that. It's just done in the hardware. So the answer to the question is, it just does it. And I want to suggest that for a great many absolutely fundamental abilities, such as our ability to see or our ability to learn a language, there may not be any theoretical mental level underlying those abilities. The brain just does them. We are neurophysiologically so constructed that the assault of photons on our photoreceptor cells enables us to see, and we are neurophysiologically so constructed that the stimulation of hearing other people talk and interacting with them will enable us to learn a language. Now, I'm not saying that rules play no role in our behavior. On the contrary, rules of language or rules of games, for example, seem to play a crucial role in the relevant behavior. But I am saying that it's a very tricky question to decide which parts of behavior are rule-governed and which are not. And we can't just assume that all meaningful behavior has some system of rules underlying it. I want to conclude this lecture on a more positive note by saying what the implications of this approach are for the study of the mind. As a way of countering the cognitivist picture, let me present an alternative approach to the solution of the problems besetting the social sciences. Let's abandon the idea that there is a computer program between the mind and the brain. Think of the mind and mental processes as biological phenomena which are as biologically based as growth or digestion or the secretion of bile. Think of our visual experiences, for example, as the end product of a series of events that begin with the assault of photons on the retina and end somewhere in the brain. Now, there will be 2 gross levels of description in the causal account of how vision takes place in animals. There will be first a level of the neurophysiology, a level at which we can discuss individual neurons, synapses, and action potentials. But within this neurophysiological level, there will be lower and higher levels of description. It isn't necessary to confine ourselves solely to neurons and synapses. We can talk about the behavior of groups or modules of neurons, such as the different levels of types of neurons in the retina or the columns in the cortex. And we can talk about the performance of the neurophysiological systems at much greater levels of complexity, such as the role of the striate cortex in vision, or the role of zones 18 and 19 in the visual cortex, or the relationship between the visual cortex and the rest of the brain in processing visual stimuli. So within the neurophysiological level, there will be a series of levels of description, all of them equally neurophysiological. Now, in addition to that, there will also be a mental level of description. We know, for example, that perception is a function of expectation. If you expect to see something, you will see it much more readily. We know, furthermore, that perception can be affected by various mental phenomena. We know that mood and emotion can affect how and what one perceives. And again, within this mental level, within this level of intentionality, there will be different levels of description. We can talk not only about how perception is affected by individual beliefs and desires, but also about how it is affected by such global mental phenomena as the person's background abilities or his general world outlook. But in addition to the level of the neurophysiology and the level of intentionality, we don't need to suppose there's another level, a level of digital computational processes. And there's no harm at all in thinking of both the level of mental states and the level of neurophysiology as information processing, provided we do not make the confusion of supposing that the real psychological information processing is the same as the as-if form of information processing. To conclude, then, where are we in our assessment of the cognitivist research program? Well, I have certainly not demonstrated that it's false. It might turn out to be true. I think its chances of success are about as great as the chances of success of behaviorism 50 years ago. That is to say, I think its chances of success are virtually nil. What I have done to argue for this, however, is simply the following three things. First, I have suggested that once you've laid bare the basic assumptions behind cognitivism, their implausibility is quite apparent. But these assumptions are, in large part, very deeply seated in our intellectual culture. Some of them are very hard to root out or even to become fully conscious of. My first claim is that once we fully understand the nature of the assumptions, their implausibility is manifest. The second point I've made is that we don't actually have sufficient empirical evidence for supposing that these assumptions are true, since the interpretation of the existing evidence rests on an ambiguity in certain crucial notions, such as the notion of information processing or rule following. And third, I've presented an alternative view, both in this lecture and the first lecture, of the relationship between the brain and the mind. A view that does not require us to postulate any intermediate level of algorithmic computational processes mediating between the neurophysiology of the brain and the intentionality of the mind. The feature of that picture which is important for this discussion is that in addition to a level of mental state, such as beliefs and desires, and a level of neurophysiology, there is no other level. No gap filler is needed between the mind and the brain because there's no gap to fill. The computer is probably no better and no worse as a metaphor for the brain than earlier mechanical metaphors. We learn as much about the brain by saying it's a computer as we do by saying it's a telephone switchboard, a telegraph system, a water pump, or a steam engine. My overall objective in these lectures is to try to answer some of the most puzzling questions about how human beings fit into the rest of the universe. In my first lecture, I tried to solve the mind-body problem. In the second, I disposed of some extreme claims that identify human beings with digital computers. In this one, I have raised some doubts about the cognitivist research program. I now want to turn my attention to explaining the structure of human actions, the nature of the social sciences, and the problem of the freedom of the will.
This is a podcast from the archives of the BBC Reith Lectures. This lecture in the series Minds, Brains and Science, given by John Searle, was originally broadcast in 1984.
The purpose of this lecture is to explain the structure of human action. I need to do that for several reasons. I need to show how the nature of action is consistent with my account of the mind-body problem and my rejection of artificial intelligence, both of which I discussed in earlier lectures. I need to explain the mental component of action and show how it relates to the physical component. I need to show how the structure of action relates to the explanation of action, and I need to lay a foundation for the discussion of the nature of the social sciences and the possibility of the freedom of the will, both of which I'll discuss in my last 2 lectures. I hope in the end that what I say will seem like a common-sense account of the structure of action. If I'm right, what I say should seem obviously right. But, as usual, common sense is not simple. In fact, it is remarkably complicated. And historically, what I think of as the common sense account of action has not seemed obvious. For one thing, the behaviorist tradition in philosophy and psychology has led many people to neglect the mental component of actions. Behaviorists wanted to define actions, and indeed all of our mental life, in terms of sheer physical movements. Somebody once characterized the behaviorist approach, justifiably in my view, as feigning anesthesia. The opposite extreme in philosophy has been to say that the only acts we ever perform are inner mental acts of volition. On this view, we don't, strictly speaking, ever raise our arms. All we do is volit that our arms go up. If they do go up, well, that's so much good luck, but not really our action. Another problem is that until recently, the philosophy of action was a somewhat neglected subject. The Western tradition has persistently emphasized knowing as more important than doing. The theory of knowledge and meaning has been more central to its concerns than the theory of action. I want now to try to draw together both the mental and the physical aspects of action, in such a way as to show both how physical actions have a mental component and how the mental component functions causally in producing the physical component. If we think about human actions, we immediately find some striking differences between them and other events in the natural world. At first, it's tempting to think that types of actions or behavior can be identified with types of bodily movements. But that's obviously wrong. For example, one and the same set of human bodily movements might constitute a dance, or signaling, or exercising, or testing one's muscles, or none of the above. Furthermore, just as one and the same set of types of physical movements can constitute completely different kinds of actions, so one type of action can be performed by a vastly different number of types of physical movements. Think, for example, of sending a message to a friend. You could write it out on a sheet of paper, you could type it, you could send it by messenger or by telegram, or you could speak it over the telephone. And indeed, each of these ways of sending the same message could be accomplished in a variety of physical movements. You could write the note with your left hand or your right hand, with your toes, or even by holding the pencil between your teeth. Furthermore, another odd feature about actions, which makes them differ from events generally, is that actions seem to have preferred descriptions. If, for example, I'm going for a walk to Hyde Park, there are any number of other things that are happening in the course of my walk. But their descriptions do not describe my intentional action, because in acting, what I'm doing depends in large part on what I think I'm doing. So, for example, I'm also moving in the general direction of Patagonia, shaking the hair on my head up and down, wearing out my shoes, and moving a lot of air molecules. However, none of these other descriptions seems to get at what is essential about this action. A third related feature of actions is that a person is in a special position to know what he's doing. He doesn't have to observe himself or conduct an investigation to see which actions he is performing, or at least trying to perform. So if you say to me, "Are you trying to walk to Hyde Park or trying to get closer to Patagonia?" I have no hesitation in giving an answer, even though the physical movements that I make might be appropriate for either answer. It's also a remarkable fact about human beings that quite effortlessly we're able to identify and explain the behavior of ourselves and of other people. I believe that this ability rests on an unconscious mastery of a certain set of principles, just as our ability to recognize something as a sentence of English rests on our having an unconscious mastery of the principles of English grammar. I believe there are a set of principles that we presuppose when we say such ordinary common sense things as that, for example, Basil voted for the Tories because he thought they would cure the problem of inflation, or Sally moved from Birmingham to London because she thought the job opportunities were better there, or even such simple things as that the man over there making such strange movements is in fact sharpening an axe or polishing his shoes. It's quite common for people who recognize the existence of these theoretical principles to sneer at them by saying that they're just a folk theory, and that they should be supplanted by some more scientific account of human behavior. I am suspicious of this claim, just as I would be suspicious of a claim that said we should supplant our implicit theory of English grammar, the one we acquired by learning the language. And the reason for my suspicion in each case is the same. Using the implicit theory is part of performing the actions in the same way that using the rules of grammar is part of speaking. So though we might add to it or discover all sorts of interesting additional things about language or about behavior, it's very unlikely that we could replace that theory which is implicit and partly constitutive of the phenomenon by some external scientific account of that very phenomenon. Aristotle and Descartes would have been completely familiar with most of our explanations of human behavior, but not with our explanations of biological and physical phenomena. The reason usually given for this is that Aristotle and Descartes had both a primitive theory of biology and physics on the one hand and a primitive theory of human behavior on the other, and that while we've advanced in biology and physics, we've made no comparable advance in the explanation of human behavior. I want to suggest an alternative view. I think that Aristotle and Descartes, like ourselves, already had a sophisticated and complex theory of human behavior. I also think that many supposedly scientific accounts of behavior, such as Freud's, for example, in fact employ rather than replace the principles of our implicit theory of human behavior. To summarize, then, what I've said so far, there's more to types of action than physical movements. Actions have preferred descriptions, people know what they're doing without observation, and the principles by which we identify and explain action are themselves part of the actions. That is, they're partly constitutive of actions. I now want to give a brief account of what we might call the structure of human behavior. In order to explain the structure of behavior, I need to introduce one or two technical terms. The key notion in the structure of behavior is the notion of intentionality. To say that a mental state has intentionality simply means that it is about something. For example, a belief is always a belief that such and such is the case, or a desire is always a desire that such and such should happen or be the case. Intending in the ordinary sense has no special role in the theory of intentionality. Intending to do something is just one kind of intentionality along with believing, desiring, hoping, fearing, and all the rest. An intentional state, like a belief or a desire or an intention in the ordinary sense, characteristically has two components. It has what we might call its content, which makes it about something, and its psychological mode or type. Now, the reason we need this distinction is that you can have the same content in different types. So, for example, I can want to leave the room, I can intend to leave the room, and I can believe that I will leave the room. In each case, we have the same content, that I will leave the room, but in different psychological modes or types, belief, desire, and intending, respectively. Furthermore, the content and the type of state will serve to relate the mental state to the world. That, after all, is why we have minds with mental states, to represent the world to ourselves, to represent how it is, how we'd like it to be, how we fear it may turn out, what we intend to do about it, and so on. Now, this has the consequence that our beliefs will be true if they match the way the world is, false if they don't. Our desires will be fulfilled or frustrated, our intentions carried out or not carried out. In general, then, intentional states have what we might call conditions of satisfaction. Each state itself determines under what conditions it's true, if, say, it's a belief, or under what conditions it's fulfilled, if, say, it's a desire, and under what conditions it's carried out, if, for example, it's an intention. In each case, the mental state represents its own conditions of satisfaction. A third feature to notice about such states is that sometimes they cause things to happen. For example, if I want to go to the movies, and I do go to the movies, normally my desire will cause the very event that it represents, my going to the movies. In such cases, there is an internal connection between the cause and the effect, because the cause is a representation of the very state of affairs that it causes. The cause both represents and brings about the effect. I call such kinds of cause and effect relations cases of intentional causation. Intentional causation, as we will see, will prove crucial both to the structure and to the explanation of human action. It is in various ways quite different from the standard textbook accounts of causation, where, for example, one billiard ball hits another billiard ball and causes it to move. For our purposes, the essential thing about intentional causation is that in such cases the mind brings about the very state of affairs that it has been thinking about. To summarize this discussion of intentionality, there are three features that we need to keep in mind in our analysis of human behavior. First, intentional states consist of a content in a certain mental type. Second, they determine their conditions of satisfaction. That is, they'll be satisfied or not depending on whether the world matches the content of the state. And third, sometimes they cause things to happen by way of intentional causation to bring about a match. That is, to bring about the state of affairs they represent, and what they represent are the very states of affairs that have to happen for them to be satisfied, their own conditions of satisfaction. Using these ideas, I'll now turn to the main task of this lecture. I promise to give a very brief account of what might be called the structure of action, or the structure of behavior. By behavior here, I mean voluntary, intentional human behavior. I mean such things as walking, running, eating, making love, voting in elections, getting married, buying and selling, going on a vacation, working on a job. I don't mean such things as digesting, growing older, or snoring. But even restricting ourselves to intentional behavior, human activities present us with a bewildering variety of types. We need to distinguish between individual behavior and social behavior, between collective social behavior and individual behavior within a social collective, between doing something for the sake of something else and doing something for its own sake. Perhaps most difficult of all, we need to account for the melodic sequences of behavior through the passage of time. Human activities, after all, are not like a series of still snapshots, but something more like the movie of our life. I obviously can't try to answer all of these questions in this lecture, but I can give you a sketch of the basic structure of action. An account of the structure of behavior can be best given by stating a set of principles. These principles should explain both the mental and physical aspects of action. In presenting them, I won't be discussing where our beliefs and desires and so on come from, but I will be explaining how they figure in our behavior. I think the simplest way to convey these principles is just to state them and then try to defend them. So here goes. Principle number 1. Actions characteristically consist of two components, a mental component and a physical component. Think, for example, of pushing a car. On the one hand, there are certain conscious experiences of effort when you push. If successful, those experiences will result in the movement of your body and the corresponding movement of the car. If you are unsuccessful, you will still have had at least the mental component. That is, you will still have had an experience of trying to move the car with at least some of the physical components. There will have been muscle tightenings, the feeling of pressure against the car, and so on. And this leads to principle number 2. The mental component is an intention. It has intentionality. It is about something. It determines what counts as success or failure in the action, and if successful, it causes the bodily movement, which in turn causes the other movements, such as the movement of the car, which constitute the rest of the action. In terms of the theory of intentionality that we just sketched, the action consists of two components, a mental component and a physical component. If successful, the mental component causes the physical component, and it represents the physical component. This form of causation I just called intentional causation. The best way to see the nature of the different components of an action is to carve each one off and examine it separately. And in fact, in a laboratory, it's easy enough to do that. We already have in neurophysiology experiments done by Wilder Penfield of Montreal, whereby electrically stimulating a certain portion of the patient's motor cortex, Penfield could cause the movement of the patient's limbs. Now, the patients were invariably surprised at this, and they characteristically said such things as, "I didn't do that, you did it." In such a case, we have carved off the bodily movement without the intention. Notice that in such cases, the bodily movements might be exactly the same as they are in an intentional action, but it seems quite clear that there's a difference. Well, what is the difference? We also have experiments, going back as far as William James, where we can carve off the mental component without the corresponding physical component of the action. In the William James case, a patient's arm is anesthetized and it is held at his side in a dark room, and he is then ordered to raise it. He does what he thinks is obeying the order, but is later quite surprised to discover that his arm didn't go up. Now, in that case, we carve off the mental component, that is to say, the intention, from the bodily movement, for the man really did have the intention. That is, we can truly say of him, he genuinely did try to move his arm. In the normal case, these two components come together. We usually have both the intention and the bodily movement, but they're not independent. What our first two principles try to articulate is how they are related. The mental component, as part of its conditions of satisfaction, has to both represent and cause the physical component. Let's turn now to principle number 3. The kind of causation which is essential both to the structure of action and the explanation of action is intentional causation. The bodily movements in our actions are caused by our intentions. Intentions are causal because they make things happen, but they also have contents and so can figure in the process of logical reasoning. They can be both causal and have these logical features because the kind of causation that we're talking about is mental causation or intentional causation. And in intentional causation, mental contents affect the world. The whole apparatus works because it's realized in the brain in the way that I explained in the first lecture. The form of causation that we're discussing here is really quite different from the standard form of causation as described in philosophical textbooks. It's not a matter of regularities or covering laws or constant conjunctions. In fact, I think it's much closer to our common sense notion of causation, where we just mean that something makes something else happen. What is special about intentional causation is that it is a case of a mental state making something else happen, and that something else is the very state of affairs represented by the mental state that causes it. Principle number 4. In the theory of action, there's a fundamental distinction between those actions which are premeditated, which are the result of some kind of planning in advance, and those actions which are spontaneous, where we do something without any prior reflection. And corresponding to this distinction, we need a distinction between prior intentions, that is, intentions formed prior to the performance of an action, and intentions in action, which are the intentions we have while we're actually performing an action. A common mistake in the theory of action is to suppose that all intentional actions are the result of some sort of deliberation, that they are the product of a chain of practical reasoning. But obviously, many things we do are not like that. We simply do something without any prior reflection. For example, in a normal conversation, one doesn't reflect on what one is going to say next. One just says it. In such cases, there is indeed an intention, but it's not an intention formed prior to the performance of the action. It's what I call an intention in action. In other cases, however, we do form prior intentions. We reflect on what we want and what's the best way to achieve it. This process of reflection, Aristotle called it practical reasoning, by the way, characteristically results either in the formation of a prior intention, or, as Aristotle also pointed out, sometimes it results in the action itself. Principle number 5. The formation of prior intentions is at least generally the result of practical reasoning. And practical reasoning is always reasoning about how best to decide between conflicting desires. The motive force behind most human and animal action is desire. Beliefs function only to enable us to figure out how best to satisfy our desires. So, for example, Suppose I want to go to Paris, and I believe that the best way, all things considered, is to go by plane. I then form the intention to go by plane. Now that's a typical and common sense piece of practical reasoning. But practical reasoning differs crucially from theoretical reasoning, from reasoning about what is the case, in that practical reasoning is always about how best to decide among various conflicting desires that we have, in a way that theoretical reasoning is not characteristically about how to decide between conflicting beliefs. So, for example, suppose I do want to go to Paris, and I figure that the best way is to go by plane. Still, there's no way I can do that without frustrating a large number of other desires that I have. I don't want to spend the money, I don't want to stand in queues at airports, I don't want to sit in airplane seats, I don't want to eat airplane food, I don't want people to put their elbow where I'm trying to put my elbow, and so on indefinitely. Nonetheless, in spite of all the desires that will be frustrated if I go to Paris by plane, I may still reason that it's best, all things considered, to go to Paris by plane. This is not only typical of practical reasoning, but I think it's universal in practical reasoning that practical reasoning concerns the adjudication of conflicting desires. Well, the picture that emerges from these 5 principles, then, is that the mental energy that powers action is an energy that works by intentional causation. It's a form of energy whereby the cause, either in the form of desires or intentions, represents the very state of affairs that it causes. Now let's go back to some of those points about action that I made at the beginning, because I think we've assembled enough pieces to explain them. We noticed that actions have preferred descriptions, and that in fact common sense enabled us to identify what the preferred descriptions of actions were. Now we can see that the preferred description of an action is determined by the intention in action. What the person is really doing, or at least what he's trying to do, is entirely a matter of what the intention is that he is acting with. For example, I know that I'm trying to get to Hyde Park and not trying to get closer to Patagonia because that's the intention with which I'm going for a walk. This furthermore explains some of the logical features about the explanations that we give of human action. To explain an action is to give its causes. Its causes are psychological states. Those states relate to the action either by being steps in the practical reasoning that led to the intentions or by being the intentions themselves. The most important feature of the explanation of action, however, is worth statement as a separate principle. So let's call it principle number 6. The explanation of an action must have the same content as was in the person's head when he performed the action or when he reasoned toward his intention to perform the action. The content that causes behavior by way of intentional causation must be identical with the content in the explanation of the behavior. Now, in this respect, actions differ from other natural events in the world, and correspondingly their explanations differ. When we explain an earthquake or a hurricane, the content in the explanation only has to represent what happened and why it happened. It doesn't actually have to cause the event itself. But in explaining human behavior, the cause and the explanation both have contents, and the explanation only explains because it has the same content as the cause. Well, so far we've been talking as if people just had intentions out of the blue. But of course that's very unrealistic, and we need now to introduce some complexities which will get our analysis at least a bit closer to the affairs of real life. No one ever just has an intention just like that by itself. For example, suppose I have an intention to drive to Oxford from London. I might have that quite spontaneously. Nonetheless, I must still have a series of other intentional states. I must have a belief that I have a car and a belief that Oxford is within driving distance. Furthermore, I will characteristically have a desire that the roads won't be too crowded and a wish that the weather won't be too bad for driving. Also, and here we get a little closer to the notion of the explanation of action, I will characteristically not just drive to Oxford, but drive to Oxford for some purpose, and if so, I will characteristically engage in practical reasoning, that form of reasoning that leads not to beliefs or conclusions of arguments, but to actual behavior. And when we understand this form of reasoning, we will have made a great step toward understanding the explanation of actions. Let's call the other intentional states that give the original intentional state the particular meaning that it has. Let's call all of them the network of intentionality. and we can say by way of a general conclusion, let's call this principle number 7, any intentional state only functions as part of a network of other intentional states. And by functions here, I mean that it only determines its conditions of satisfaction relative to a whole lot of other intentional states. Now, when we begin to probe the details of the network, we discover another interesting phenomenon. And that is simply that the activities of our mind cannot consist in mental states, so to speak, right down to the ground. Rather, our mental states only function in the way they do because they function against a background of capacities, abilities, skills, habits, ways of doing things, and general stances toward the world that do not themselves consist in intentional states. In order for me so much as to form the intention to drive to Oxford, I have to have the ability to drive. But the ability to drive doesn't itself consist in a whole lot of other intentional states. It takes more than a bunch of beliefs and desires and so on. In order to be able to drive, I actually have to have the skill to do it. This is a case where my knowing how is not just a matter of knowing that. Now let's call a set of skills, habits, abilities, and so on against which intentional states function the background of intentionality. And to the thesis of the network, namely the thesis that any intentional state only functions as a part of a network, let us add the thesis of the background, call it principle number 8. The whole network of intentionality only functions against a background of human capacities that are not themselves mental states. I said that many supposedly scientific accounts of behavior try to escape from or surpass this common sense model that I've been sketching. But in the end, there's no way I think they can do that, because these principles don't just describe the phenomena, they themselves partly go to make up the phenomena. Consider, for example, Freudian explanations. When Freud is doing his meta-psychology, that is, when he's giving us a theory of what he's doing, he often uses scientific comparison. There are a lot of analogies between psychology on the one hand and electromagnetism and hydraulics on the other, and we're to think of the mind as functioning on the analogy of some sort of hydraulic principles. But when he's actually examining a patient and actually describing the nature of some patient's neurosis, it is surprising how much the explanations he gives are common sense explanations. So Dora behaves the way she does because, for example, she's in love with Herr K, or because she's imitating her cousin who's gone off to Mariazell. Now, what Freud adds to common sense is the observation that often the mental states that cause our behavior are unconscious. Indeed, they're repressed. We're often resistant to admitting to having certain intentional states because we're ashamed of them or for some other reason. And secondly, Freud also adds a theory of the transformations of mental states, how one sort of intentional state can be transformed into another. But with the addition of these and other such accretions, the Freudian form of explanation is very much the same as the common sense form. And I suggest that common sense is likely to persist even as we acquire other more scientific accounts of behavior. Since the structure of the explanation has to match the structure of the phenomena explained, improvements in explanation are not likely to have new and unheard of structures. In this lecture, I've tried to explain how and in what sense behavior both contains and is caused by internal mental states. It may seem surprising that many psychologists and cognitive scientists have tried to deny these relations. The reasons for this derive from a certain conception they have of science. They think a scientific account of human behavior should not be founded on a common sense conception of mental states. They think, in my view incorrectly, that a scientific account of human behavior cannot be based on such subjective mental phenomena as beliefs, desires, hopes, fears, and so on. I have argued that an account of action must be based on these phenomena if it is to succeed.
This is a podcast from the archives of the BBC Reith Lectures. This lecture in the series Minds, Brains and Science, given by John Searle, was originally broadcast in 1984.
In this lecture, I want to discuss one of the most vexing intellectual problems of the present era. Why have the methods of the natural sciences not given us the kind of payoff in the study of human behavior that they have in subjects like physics and chemistry? And what sort of social or behavioral sciences can we reasonably expect anyhow? I'm going to suggest that there are certain radical differences between human behavior and the phenomena studied in the natural sciences. And I'll argue that these differences account both for the failures and the successes that the methods of the natural sciences have had in the human sciences. At the beginning, I want to call your attention to an important difference between the form of common sense explanations of human behavior and the standard form of scientific explanations. According to the standard theory of scientific explanation, explaining a phenomenon consists in showing how its occurrence follows from certain scientific laws. These laws are universal generalizations about how things happen. For example, if you are given a statement of the relevant laws describing the behavior of a falling body, and you know where it started from, you can actually deduce what will happen to it. Similarly, if you want to explain a law, you can deduce the law from some higher level law. On this account, explanation and prediction are perfectly symmetrical. You predict by deducing what will happen, you explain by deducing what has happened. Now, whatever merit this type of explanation may have in the natural sciences, one of the things I want to emphasize in this lecture is that it is quite worthless to us in explaining human behavior. And this is not because we lack laws for explaining individual examples of human behavior, but rather it's because even if we had such laws, they would still be useless to us. And I think I can easily get you to see that by asking you to imagine what it would be like if we actually had a law, that is, a universal generalization, concerning some aspect of behavior. Suppose that in the last election you voted for the Tories, and suppose that you voted for the Tories because you thought they would do more to solve the problem of inflation than any of the other parties. Now let's suppose that's just a plain fact about why you voted for the Tories, as it is an equally plain fact that you did vote for the Tories. Suppose, furthermore, that some political sociologists come up with an absolutely exceptionalist universal generalization about people who exactly fit your description, your socioeconomic status, your income level, your education, your other interests, and so on. Suppose this absolutely exceptionalist generalization is to the effect that people like you invariably vote for the Tories. Now I want to ask, which explains why you voted for the Tories? Is it the reason you sincerely accept, or is it the universal generalization? I believe we would never accept the generalization as the explanation of our own behavior. The generalization states a regularity, and knowledge of such a regularity may be useful for prediction, but it doesn't explain anything about individual cases of human behavior. If a generalization were found, it itself would require explanation of the sort we were after in the first place. And where human behavior is concerned, the sort of explanation we normally seek is one that specifies the mental states, the beliefs, fears, hopes, desires, and so on, that function causally in the production of the behavior. Well, let's return to our original question. Why do we not seem to have laws of social sciences in the sense that we have laws of the natural sciences? Now, there are several standard answers to that question. Some philosophers point out that we don't have a science of behavior for the same reason that we don't have a science of furniture. We couldn't have such a science because there aren't any physical features that all furniture, chairs, tables, rugs, and other such items have in common that will enable them to fall under a common set of laws of furniture. And besides, they argue, we don't really need such a science because anything we want to explain, for example, why are wooden tables solid or why does iron lawn furniture rust, can already be explained by existing sciences. Similarly, there aren't any features that all human behaviors have in common. And besides, particular things we wish to explain can be explained by physics and physiology and all the rest of the existing sciences. In a related argument, some philosophers point out that perhaps our concepts for describing ourselves and other human beings don't match the concepts of such basic sciences as physics and chemistry in the right way. Perhaps they suggest human science is like a science of the weather. We have a science of the weather, meteorology, but it's not a strict science because the things that interest us about the weather don't match the natural categories we have for physics. So weather concepts such as bright spots over the Midlands or partly cloudy in London are not systematically related to the concepts of physics. A powerful expression of this sort of view is in Jerry Fodor's work. He suggests that special sciences like geology or meteorology are about features of the world that can be realized in physics in a variety of ways, and that this loose connection between the special sciences and the more basic science of physics is also characteristic of the social sciences. Just as mountains and storms can be realized in different sorts of microphysical structures, so money, for example, can be physically realized as gold or silver or printed paper. And such disjunctive connections between the higher-order phenomena and the lower-order do indeed allow us to have rich sciences, but they do not allow for strict laws because the form of the loose connections will permit of laws that have exceptions. Another argument for the view that we cannot have strict laws connecting the mental and the physical is in Donald Davidson's claim that the concepts of rationality, consistency, and coherence are partly constitutive of our notion of mental phenomena, and these notions simply don't relate systematically to the notions of physics. As Davidson says, they have no echo in physics. But a difficulty with this view is that there are lots of sciences which contain constitutive notions that similarly have no echo in physics, but are nonetheless pretty solid sciences. Biology, for example, requires the concept of organism, and organism has no echo in physics, but biology does not thereby cease to be a hard science. Another view, widely held, is that the complex interrelations of our mental states prevent us from ever getting a systematic set of laws connecting them to neurophysiological states. But once again, this argument is inconclusive. Suppose, for example, that Noam Chomsky's right in thinking that each of us has a complex set of rules of universal grammar programmed into our brains at birth. Well, there's nothing about the complexity or the interdependence of the rules of universal grammar that prevents them from being systematically realized in the neurophysiology of the brain. Interdependence and complexity by themselves are not a sufficient argument against the possibility of strict psychophysical laws. Well, I find all of these accounts suggestive, but I do not believe that they adequately capture the really radical differences between the mental and the physical sciences. The relation between sociology and economics on the one hand and physics on the other is really quite unlike the relation, for example, of meteorology, geology, and biology and other special sciences to physics, and we need to try to state exactly how. Now, ideally, I'd like to be able to give you a step-by-step argument to show the limitations on the possibilities of strict social sciences, and yet at the same time show the real nature and power of these disciplines. I think we need to abandon once and for all the idea that the social sciences are like physics before Newton, and that what we're waiting for is a set of Newtonian laws of the human mind. Well, first one might ask, what exactly is the problem supposed to be? One might say, surely social and psychological phenomena are as real as anything else, so why can't there be laws of their behavior? Why should there be laws of the behavior of molecules, but not laws of the behavior of societies? One way to disprove a thesis is to imagine that it's true and then show how that supposition is somehow absurd. So let's suppose that we actually had laws of society and laws of history that would enable us to predict when there would be wars and revolutions. The real problem is this. Whatever else wars and revolutions are, they involve lots of molecule movements, but that has the consequence that any strict laws about wars and revolutions would have to match perfectly with the laws about molecule movements. In order for a revolution to start on such and such a day, the relevant molecules would have to be blowing in the right direction. But if that's so, then the laws that predict the revolution will have to make the same predictions at the level of revolutions and their participants that the laws of molecule movements make at the level of the physical particles. So now our original question can be reformulated. Why can't the laws at the higher level, the level of revolutions, match perfectly with the laws at the lower level, the level of particles? Well, to see why they can't, let's examine some cases where there really is a perfect match between the higher order laws and the lower order laws, and then we can see how these cases differ from the social cases. One of the all-time successes in reducing the laws at one level to those of a lower level is the reduction of the gas laws, Boyle's law and Charles' law, to the laws of statistical mechanics. How does the reduction work? The gas laws concern the relations between pressure, temperature, and volume of gases. They predict, for example, that if you increase the temperature of a gas in a cylinder, you will increase the pressure on the walls of the cylinder. The laws of statistical mechanics concern the behavior of masses of small particles. They predict, for example, that if you increase the rate of movement of the particles in a gas, more of the particles will hit the walls of the cylinder and will hit them harder. Now, the reason you get a perfect match between these two sets of laws is that the explanation of temperature, pressure, and volume can be given entirely in terms of the behavior of the particles. Increasing the temperature of the gas increases the velocity of the particles, and increasing the number and velocity of the particles hitting the cylinder walls increases the pressure. So it follows that an increase in temperature will produce an increase in pressure. Now, suppose for the sake of argument that it wasn't like that. Suppose there was no explanation of pressure and temperature in terms of the behavior of more fundamental particles. Then any laws at the level of pressure and temperature would be simply miraculous, because it would be miraculous that the way that pressure and temperature were going on coincided exactly with the way that the particles were going on, if there was no systematic relation between the behavior of the system at the level of pressure and temperature and the behavior of the system at the level of the particles. Well, this example is a very simple case, so let's take a slightly more complex example. It is a law of nutrition science that caloric intake equals caloric output plus or minus fat deposit. That's not a very fancy law, perhaps, but it's pretty realistic nonetheless. It has the consequence, known to most of us, that if you eat a lot and you don't exercise enough, you get fat. Now, this law, unlike the gas laws, is not grounded in any simple way in the behavior of the particles. The grounding isn't simple because, for example, there's a rather complex series of processes by which food is converted into fat deposits in living organisms. Nonetheless, there's still a grounding, however complex, of this law in terms of the behavior of more fundamental particles. Other things being equal, when you eat a lot, the molecules will be blowing in exactly the right direction to make you fat. Well, now, given these examples, we can argue further towards the conclusion that there will be no laws of wars and revolutions in a way that there are laws of gases and of nutrition. The phenomena in the world that we pick out with concepts like war and revolution, marriage, money, and property are not grounded systematically in the behavior of elements at the more basic level in a way that the phenomena that we pick out with concepts like fat deposit and pressure are grounded systematically in the behavior of elements at the more basic level. But now the question arises, if the social and psychological phenomena aren't grounded in this way, why aren't they? Why couldn't they be? Granted that they're not so grounded, why not? That is, wars and revolutions, like everything else, consist of molecule movements. So why can't such social phenomena as wars and revolutions be systematically related to molecule movements in the same way that the relations between caloric inputs and fat deposits are systematic? Well, to see why this can't be so, we have to ask what features social phenomena have that enable us to bind them into categories. What are the fundamental principles on which we categorize psychological and social phenomena? One crucial feature is this. For a large number of social and psychological phenomena, the concept that names the phenomenon is itself a constituent of the phenomenon. So in order for something to count as a marriage ceremony or a trade union or property or money or even a war or revolution, people involved in these activities have to have certain appropriate thoughts. And in general, they have to think that's what it is. So, for example, in order to get married or buy property, you and other people have to think that that's what you're doing. Now, this feature is crucial to social phenomena, but there's nothing like it in the biological and physical sciences. Something can be a tree or a plant, or some person can have tuberculosis even if no one thinks, here's a tree, or here's a plant, or this is a case of tuberculosis, and even if no one thinks about it at all. But many of the terms that describe social phenomena have to enter into their very constitution. And this has the further result that such terms have a peculiar kind of self-referentiality. The concept money refers to whatever people use as and think of as money. Promise refers to whatever people intend as and regard as promises. I'm not saying that in order to have the institution of money, people have to have that very word or some exact synonym in their vocabulary. Rather, they must have certain thoughts and attitudes about something in order that it count as money, and these thoughts and attitudes are part of the very definition of money. Now, there's another crucial consequence of this feature. The defining principles of such social phenomena set no physical limits whatever on what can count as the physical realization of them. And this means that there can't be any systematic connections between the physical and the social or mental properties of the phenomenon. The social features in question are determined in part by the attitudes we take toward them. The attitudes we take toward them are not constrained by the physical features of the phenomena in question. Therefore, there can't be any matching of the mental level and the level of the physics of the sort that would be necessary to make strict laws of the social sciences possible. So the main step in the argument for radical discontinuity between the social sciences and the natural sciences depends on the mental character of social phenomena. And it's this feature which all those analogies I mentioned earlier, that is, between meteorology, biology, and geology, neglect. The radical discontinuity between the social disciplines on the one hand and the natural sciences on the other derives from the role of the mind in the social disciplines. Consider Fodor's claim that social laws will have exceptions, since the phenomena at the social level map loosely or disjunctively onto the physical phenomena. Once again, this doesn't account for the radical discontinuities I've been calling attention to. Even if this sort of disjunction had been true up to a certain point, it's always open to the next person to add to it in indefinitely many ways. Suppose money had always taken a limited range of physical forms, gold, silver, and printed paper, for example. Still, it's open to the next person or society to treat something else as money. And indeed, the physical realization of money doesn't matter to the properties of money, as long as the physical realization enables the stuff to be used as a medium of exchange. Well, somebody might object to me, in order to have a rigorous social science, we don't need a strict match between properties of things in the world. All we need is a strict match between the psychological properties and features of the brain. The real grounding of economics and sociology in the physical world is not in the properties of objects we find around us, it is in the physical properties of the brain. So even if thinking that something is money is essential to its being money, still thinking that it's money may well be, and indeed on your own account is, a process in the brain. So in order to show that there can't be any strict laws of social sciences, you have to show that there can't be any strict correlations between mental states and brain state types, and you haven't shown that. Well, to see why there can't be such correlations, let's examine some areas where it seems likely that we will get a strict neuropsychology, that is, strict laws correlating mental phenomena and neurophysiological phenomena. Consider pain, for example. It seems reasonable to suppose that neurophysiological causes of pains, at least in human beings, are quite limited and specific. Indeed, we discussed some of them in an earlier lecture. There seems to be no obstacle in principle to having a perfect neurophysiology of pain. But what about, say, vision? Well, once again, it's hard to see any obstacle in principle to getting an adequate neurophysiology of vision. We might even get to the point where we could describe perfectly the neurophysiological conditions for having certain sorts of visual experiences. The experience of seeing that something is red, for instance. But now here comes the hard part. Though we might get systematic correlations between neurophysiology and pain, or neurophysiology and the visual experience of red, we couldn't get similar accounts of the neurophysiology of seeing that something was money. Why not? Granted that every time you see that there's some money in front of you, some neurophysiological process goes on, what's to prevent it from being the same process every time? Well, from the fact that money can have an indefinite range of physical forms, it follows that it can have an indefinite range of stimulus effects on our nervous systems. But since it can have an indefinite range of stimulus patterns on our nervous systems, it would once again be a miracle if they all produced exactly the same neurophysiological effect on the brain. And what goes for seeing that something is money goes even more forcefully for believing that it's money. It would be nothing short of miraculous if every time someone believed that he was short of money, in whatever language and culture he had this belief in, it had exactly the same type of neurophysiological realization. And that's simply because the range of possible neurophysiological stimuli that could produce that very belief is infinite. Paradoxically, the way that the mental infects the physical prevents there ever being a strict science of the mental. Notice that in cases where we do not have this sort of interaction between the social and the physical phenomena, this obstacle to having strict social sciences is not present. Consider the example I mentioned earlier of Chomsky's hypothesis of universal grammar. Suppose each of us has innately programmed in our brains the rules of universal grammar. Since these rules are in the brain at birth and independent of any relations the organism has with the environment, there's nothing in my argument to prevent there being strict psychophysical laws connecting these rules and features of the brain, however interrelated and complicated the rules might be. Well, I promise to try to give you at least the sketch of a step-by-step argument. Let's see how far I got in keeping the promise. Let's set the argument out as a series of steps. Step 1. For there to be laws of the social sciences, in the sense in which there are laws of physics, there must be some systematic correlation between phenomena identified in social and psychological terms and phenomena identified in physical terms. It can be as complex as the way that weather phenomena are connected with the phenomena of physics, but there has to be some systematic correlation. In the contemporary jargon, there have to be some bridge principles between the higher and the lower levels. Step 2. Social phenomena are in large part defined in terms of the psychological attitudes that people take. What counts as money or a promise or a marriage is in large part a matter of what people think of as money, a promise, or marriage. 3. This has the consequence that these categories are physically open-ended. There is, strictly speaking, no physical limit to what we can regard as or stipulate to be money or a promise or a marriage ceremony. 4. That implies that there can't be any bridge principles between the social and the physical features of the world. That is, between phenomena described in social terms and the same phenomena described in physical terms. We can't even have the sort of loose disjunctive principles we have for the weather or digestion. 5. Furthermore, it's impossible to get the right kind of bridge principles between phenomena described in mental terms and phenomena described in neurophysiological terms, that is, between the brain and the mind, and this is because there is an indefinite range of stimulus conditions for any given social concept. This enormous range prevents concepts that are not built into us from being realized in a way that systematically correlates mental and physical features. I want to conclude this lecture by describing what seems to me the true character of the social sciences. The social sciences in general are about various aspects of intentionality. Economics is about the production and distribution of goods and services. Notice that the working economist can simply take intentionality for granted. He assumes that entrepreneurs are trying to make money and that consumers would prefer to be better off rather than worse off. And the laws of economics then state systematic fallouts or consequences of such assumptions. Given certain assumptions, the economist can deduce that rational entrepreneurs will sell where their marginal cost equals their marginal revenue. Now notice that the law doesn't predict that the businessman asks himself, am I selling where my marginal cost equals my marginal revenue? No, the law doesn't state the content of individual intentionality. Rather, it works out the consequences of such intentionality. The theory of the firm in microeconomics works out the consequences of certain assumptions about the desires and possibilities of consumers and businesses engaging in buying, producing, and selling. Macroeconomics works out the consequences of such assumptions for whole nations and societies. Since economics is grounded not in systematic facts about physical properties such as molecular structure, in the way that, for example, chemistry is grounded in systematic facts about molecular structure, but rather, economics is grounded in facts about human intentionality, about desires, practices, states of technology, and states of knowledge. It follows that economics cannot be free of history or context. Economics as a science presupposes certain historical facts about people and societies that are not themselves part of economics. And when those facts change, economics as a subject has to change. For example, until recently, the Phillips curve, a formula relating a series of factors in industrial societies, seemed to give an accurate description of economic realities in those societies. Well, lately it hasn't worked so well. I think most economists believe that this is because it didn't accurately describe reality. But they might consider, perhaps it did accurately describe reality as it was at that time. However, after the oil crises and various other events of the 70s, reality changed. Economics is a systematic, formalized science, but it's not independent of context or free of history. It is grounded in human practices, but those practices are not themselves timeless, eternal, or inevitable. Well, let's now turn to linguistics. The standard contemporary aim of linguistics is to state the various rules, phonological, syntactic, and semantic, that relate sounds and meanings in the various natural languages. An ideally complete science of linguistics would give the complete set of rules for every natural human language. I'm not sure that this is the right goal for linguistics, or even that it's a goal that's possible of attainment. But for the present purposes, the important thing to note is that it is once again an applied science of intentionality. It's not in the least like chemistry or geology. It's concerned with specifying those historically determined intentional contents in the minds of speakers of the various languages that are actually responsible for human linguistic competence. As with economics, the glue that binds linguistics together is human intentionality. The upshot of this fifth lecture can now be stated quite simply. The radical discontinuity between the social and the natural sciences doesn't come from the fact that there's only a disjunctive connection of social and physical phenomena. It doesn't even come from the fact that social disciplines have constitutive concepts which have no echo in physics, nor even from the great complexity of social life. Many disciplines, such as geology, biology, and meteorology, have these features, but that does not prevent them from being systematic natural sciences. No, the radical discontinuity derives from the intrinsically mental character of social and psychological phenomena. The fact that the social sciences are powered by the mind is the source of their weakness vis-à-vis the natural sciences, but it's also precisely the source of their strength as social sciences. What we want from the social sciences and what we get from the social sciences at their best are theories of pure and applied intentionality.
This is a podcast from the archives of the BBC Reith Lectures. This lecture in the series Minds, Brains and Science, given by John Searle, was originally broadcast in 1984.
In these lectures, I have tried to answer what are to me some of the most worrisome questions about how we as human beings fit into the rest of the universe. Our conception of ourselves as free agents is fundamental to our overall self-conception. Now, ideally, I would like to be able to keep both my common sense conceptions and my scientific beliefs. In the case of the relation between mind and body, for example, I was able to do that. But when it comes to the question of freedom and determinism, I am, like a lot of other philosophers, unable to reconcile the two. One would think that after over 2,000 years of worrying about it, the problem of the freedom of the will would by now have been finally solved. Well, actually, most philosophers think it has been solved. They think it was solved by Thomas Hobbes and David Hume and various other empirically minded philosophers whose solutions have been repeated and improved right into the 20th century. I think it has not been solved. In this lecture, I want to give you an account of what the problem is and why the contemporary solution is not a solution, and then conclude by trying to explain why the problem is likely to stay with us. On the one hand, we're inclined to say that since nature consists of particles and their relations with each other, and since everything can be accounted for in terms of those particles and their relations, there is simply no room for freedom of the will. As far as human freedom is concerned, it doesn't matter whether physics is deterministic, as Newtonian physics was, or whether it allows for randomness or indeterminacy at the level of particle physics, as contemporary quantum mechanics does. Indeterminism at the level of particles in physics is really no support at all to any doctrine of the freedom of the will. Because first, the statistical indeterminacy at the level of particles does not show any indeterminacy at the level of the objects that matter to us, human bodies, for example. And secondly, even if there is an element of indeterminacy in the behavior of physical particles, even if they are only statistically predictable, still, that by itself gives no scope for human freedom of the will. It doesn't follow from the fact that particles are only statistically determined that the human mind can force the statistically determined particles to swerve from their paths. The strongest image for conveying this conception of determinism is still that formulated by Laplace. If an ideal observer knew the positions of all the particles at a given instant and knew all the laws governing their movements, he could predict and retrodict the entire history of the universe. Some of the predictions of a contemporary quantum mechanical Laplace might be statistical, but they would still allow no room for freedom of the will. Well, so much for the appeal of determinism. Now let's turn to the argument for the freedom of the will. As many philosophers have pointed out, if there is any fact of experience that we're all familiar with, it's the simple fact that our own choices, decisions, reasonings, and cogitations seem to make a difference to our actual behavior. There are all sorts of experiences that we have in life where it seems just a fact of our experience that though we did one thing, we know, or at least think we know, perfectly well that we could have done something else. We know we could have done something else because we chose one thing for certain reasons. But we were aware that there were also reasons for choosing something else, and indeed we might have acted on those reasons and chosen that something else. Another way to put this point is to say it's just a plain empirical fact about our behavior that it isn't predictable in the way that the behavior of objects rolling down an inclined plane is predictable. And the reason it isn't predictable in that way is that we could often do otherwise than we in fact did. Human freedom is just a fact of experience, and if we want some empirical proof of this fact, we can simply point to the further fact that it's always up to us to falsify any predictions that anybody might care to make about our behavior. If somebody predicts that I'm going to do something, I might just damn well do something else. Now, that sort of option is simply not open to glaciers moving down mountainsides or balls rolling down inclined planes or the planets moving in their elliptical orbits. This is a characteristic philosophical conundrum. On the one hand, a set of very powerful arguments force us to the conclusion that free will has no place in the universe. On the other hand, a series of powerful arguments based on facts of our own experience inclines us to the conclusion that there must be some freedom of the will because we all experience it all the time. Now, there's a standard solution to this philosophical conundrum. According to this solution, free will and determinism are perfectly compatible with each other. Of course, according to this solution, everything in the world is determined, but some actions are nonetheless free. To say that they are free is not to deny that they are determined. It's just to say that they are not constrained. We're not forced to do them. So, for example, if a man is forced to do something at gunpoint, or if he's suffering from some psychological compulsion, then his behavior is genuinely unfree. But if, on the other hand, he freely acts, if he acts, as we say, of his own free will, then his behavior is free. Of course, it's also completely determined, since every aspect of his behavior is determined by the physical forces operating on the particles that compose his body, as they operate on all of the bodies in the universe. So, according to this view, free behavior exists, but it's just a small corner of the determined world. It's that corner of determined behavior where certain kinds of force and compulsion are absent. Now, because this view asserts the compatibility of free will and determinism, it's usually called simply compatibilism. I think it's inadequate as a solution to the problem, and here's why. The problem about the freedom of the will is not about whether or not there are inner psychological reasons that cause us to do things, as well as external physical causes and inner compulsions. Rather, it's about whether or not the causes of our behavior, whatever they are sufficient to determine the behavior so that things have to happen the way they do happen. And there's another way to put this problem. Is it ever true to say of a person that he could have done otherwise, all other conditions remaining the same? For example, given that a person chose to vote for the Tories, could he have chosen to vote for one of the other parties, all other conditions remaining the same? Now, compatibilism doesn't really answer that question in a way that allows any scope for the ordinary notion of the freedom of the will. What it says is that all behavior is determined in such a way that it couldn't have occurred otherwise, all other conditions remaining the same. Everything that happened was indeed determined. It's just that some things were determined by certain sorts of inner psychological causes, those which we call our reasons for acting, and not by external forces or psychological compulsions. So we're still left with a problem. Is it ever true to say of a human being that he could have done otherwise? Compatibilism, in short, denies the substance of free will while maintaining its verbal shell. Well then, let's try to make a fresh start. I said that we have a conviction of our own free will simply based on the facts of human experience. But perhaps our belief that such experiences support the doctrine of human freedom is illusory. Consider this sort of example. A typical hypnosis experiment has the following form. Under hypnosis, the patient is given a post-hypnotic suggestion. You can tell him, for example, to do some fairly trivial, harmless things such as, let's say, crawl around on the floor. Now, after the patient comes out of hypnosis, he might be engaging in conversation, sitting, drinking coffee, when suddenly he says something like, "What a fascinating floor in this room," or "I want to check out this rug," or "I'm thinking of investing in floor coverings and I'd like to investigate the coverings on this floor." And he then proceeds to crawl around on the floor. Now, the interest of these cases is that the patient always gives some more or less adequate reason for doing what he does. That is, he seems to himself to be behaving freely. We, on the other hand, have good reasons to believe that his behavior isn't free at all, that the reasons he gives for his apparent decision to crawl around on the floor are irrelevant, that his behavior was determined in advance, that he is, in short, in the grip of a post-hypnotic suggestion. Now, one way to pose the problem of determinism, or at least one important aspect of the problem of determinism is all human behavior like that? But now, if we take that example seriously, it looks as if it proves to be an argument for the freedom of the will and not against it. The agent thought he was acting freely, though in fact his behavior was determined. But it seems empirically very unlikely that all human behavior is like that. Sometimes people are indeed suffering from the effects of hypnosis, and sometimes we know that they're in the grip of unconscious urges which they cannot control. But are they always like that? Is all human behavior determined by such psychological compulsions? The thesis of psychological determinism is that prior psychological causes determine all of our behavior in the way that they determine the behavior of the hypnosis subject or the heroin addict. On this view, all behavior in one way or another is psychologically compulsive, but the available evidence suggests that such a thesis is false. We do indeed normally act on the basis of our intentional states, our beliefs, hopes, fears, desires, and so on. And in that sense, our mental states function causally. But this form of cause and effect relation is not deterministic. We might have had exactly those mental states and still not have done what we did. Instances of hypnosis and psychologically compulsive behavior on the one hand are usually pathological and easily distinguishable from normal free action on the other. So psychologically speaking, there does seem to be scope for human freedom. But is this solution really an advance on compatibilism? Aren't we just saying, once again, yes, all behavior is determined, but what we call free behavior is the sort determined by rational thought processes? Sometimes the conscious, rational thought processes don't make any difference, as in the hypnosis case, and sometimes they do, as in the normal case. But of course, those normal, rational thought processes are as much determined as anything else. So once again, don't we have the result that everything we do was entirely written in the book of history billions of years before we were born, and therefore nothing we do is free in any philosophically interesting sense? If we choose to call our behavior free, that's just a matter of adopting a traditional terminology, just as we continue to speak of sunsets even though we know perfectly well that the sun doesn't literally set. So we continue to speak of acting of our own free will, even though there is no such phenomenon. One way to examine a philosophical thesis, or any other kind of a thesis for that matter, is to ask, what difference would it make? How would the world be any different if that thesis were true, as opposed to how the world would be if that thesis were false? Now, part of the appeal of determinism, I believe, is that it seems to be consistent with the way the world in fact proceeds, at least as far as we know anything about it from physics. That is, if determinism were true, then the world would proceed pretty much the way it does proceed, the only difference being that certain of our beliefs about its proceedings would be false. But if libertarianism, that is, the thesis of free will, were true, it appears we would have to make some really radical changes in our beliefs about the world. In order for us to have radical freedom, then it looks as if we would have to postulate that inside each of us was a self that was capable of interfering with the causal order of nature. That is, it looks as if we would have to contain some entity that was capable of making molecules swerve from their paths. I don't know if such a view is even intelligible, but it's certainly not consistent with what we know about how the world works from physics, and there's not the slightest evidence to suppose that we should abandon physical theory in favor of such a view. Well, so far, then, we seem to be getting exactly nowhere in our effort to resolve the conflict between determinism and the belief in the freedom of the will. Science seems to allow no place for freedom of the will, and indeterminism in physics offers no support for the freedom of the will. On the other hand, we seem to be unable to give up the belief in the freedom of the will. So let's investigate both of these points a bit further. Why exactly is there no room for the freedom of the will on the contemporary scientific view of the universe? Our basic explanatory mechanisms in physics work from the bottom up. That is to say, we explain the behavior of surface features of a phenomenon, such as the transparency of glass or the liquidity of water, in terms of the behavior of microparticles such as molecules. And the relation of the mind to the brain is an example of such a relation. But we get causation from the mind to the body. That is, we get top-down causation over a passage of time. And we get top-down causation over time because the top level and the bottom level go together. So, for example, Suppose I want to cause the release of the neurotransmitter acetylcholine at the axon end plates of my motor neurons. Now, I can do that by simply deciding to raise my arm and then raising it. Here, the mental event, the intention to raise my arm, causes the physical event, the release of acetylcholine. And that's a case of top-down causation, if ever there was one. But such cases of top-down causation only work because the mental events are grounded in the neurophysiology to start with. So corresponding to the description of the causal relations that go from the top to the bottom, there's another description of the same series of events where the causal relations bounce entirely along the bottom. That is, they are entirely a matter of neurons and neuron firings at synapses, and so on. Now, as long as we accept this conception of how nature works, then it doesn't seem that there's any scope for the freedom of the will, because on this conception, the mind can only affect nature insofar as it is already a part of nature. But if so, then like the rest of nature, its features are determined at the basic micro levels of physics. This is actually an absolutely fundamental point in this lecture, so let me repeat it. The form of determinism that is ultimately worrisome is not psychological determinism. The idea that our states of mind are sufficient to determine everything we do is probably just false. The worrisome form of determinism is more basic and fundamental. Since all of the surface features of the world are entirely caused by and realized in systems of microelements, then the behavior of microelements is sufficient to determine everything that happens. Such a bottom-up picture of the world allows for top-down causation. Our minds, for example, can affect our bodies, but the top-down causation only works because the top level is already caused by and realized in the bottom levels. Well, then, let's turn to the next obvious question. What is it about our experience that makes it impossible for us to abandon the belief in the freedom of the will? If freedom is an illusion, why is it an illusion we seem unable to abandon? The first thing to notice about our conception of human freedom is that it is essentially tied to consciousness. We only attribute freedom to conscious beings. Suppose, for example, somebody built a robot which we believe to be totally unconscious. In such a case, we would never feel any inclination to call it free. Even if we found its behavior random and unpredictable, we would not say that it was acting freely in the sense that we think of ourselves as acting freely. If, on the other hand, somebody built a robot that we became convinced had consciousness, in the same sense that we do, then it would at least be an open question whether or not that robot had freedom of the will. The second point to note is that it is not just any state of consciousness that gives us the conviction of human freedom. If life consisted entirely of the reception of passive perceptions, then it seems to me we would never so much as form the idea of human freedom. If you imagine yourself totally immobile, totally unable to move, and unable to determine even the course of your own thoughts, but still receiving stimuli, for example, say, periodic mildly painful sensations, there would not in such a case be the slightest inclination to conclude that you had freedom of the will. I said earlier that most philosophers think that the conviction of human freedom is somehow essentially tied to the process of rational decision-making. But I think that's only partly true. In fact, weighing up reasons is only a very special case of the experiences that give us the conviction of freedom. The characteristic experience that gives us the conviction of human freedom, and it is an experience from which we are unable to strip away the conviction of freedom, is the experience of engaging in voluntary, intentional human actions. Now, it's that sort of experience which is the foundation stone of our belief in the freedom of the will. Why? Reflect very carefully on the character of the experiences you have as you engage in normal, everyday, ordinary human actions. You will sense the possibility of alternative courses of action built into these experiences. If you raise your arm or walk across the room or take a drink of water, you will see that at any point in the experience you have a sense of alternative courses of action open to you. If one tried to express it in words, the difference between the experience of perceiving and the experience of acting is that in perceiving one has the sense, this is happening to me. But in acting, one has the sense, I am making this happen. But the sense that I am making this happen carries with it the sense, I could be doing something else. In normal behavior, each thing we do carries the conviction, valid or invalid, that we could be doing something else right here and now. That is, all other conditions remaining the same. And this, I submit, is the source of our unshakable conviction in our own free will. It is perhaps important to emphasize that I'm discussing normal human action. If one is in the grip of a great passion, for example, if one is in the grip of a great rage, one loses this sense of freedom, and one can even be surprised to discover what one is doing. Now, once we notice this feature of the experience of acting, a great deal of the puzzling phenomena I mentioned earlier is easily explained. Why, for example, do we feel that the man in the case of post-hypnotic suggestion is not acting freely in the sense in which we are, even though he might think that he is acting freely? Well, the reason is that in an important sense he doesn't know what he's doing. His actual intention in action is totally unconscious. The options that he sees as available to him are irrelevant to the actual motivation of his behavior. Notice also that the compatibilist examples of so-called forced or compelled behavior still, in many cases, involve the experience of freedom. If, for example, I'm instructed to walk across the room at gunpoint, still part of the experience is that I sense that it's literally open to me at any step to do something else. The experience of freedom is thus an essential component of any case of acting with an intention. Again, you can see this if you contrast the normal case of action with the Penfield cases where stimulation of the motor cortex produces an involuntary movement of the arm or leg. In such a case, the patient would experience the movement passively, as he would experience a sound or a sensation of pain. Unlike intentional actions, there are no options built into this experience. To see this point clearly, try to imagine that a portion of your life was like the Penfield experiments on a grand scale. Instead of walking across the room, you simply find that your body is moving across the room. Instead of speaking, you simply hear and feel words coming out of your mouth. Imagine your experiences are those of a purely passive but conscious puppet, and you will have imagined away the experience of freedom. But in the typical case of intentional action, there's no way we can carve off the experience of freedom. It is an essential part of the experience of acting. This also explains, I believe, why we cannot give up our conviction of freedom. We find it easy enough to give up the conviction that the Earth is flat as soon as we understand the evidence for the heliocentric theory of the solar system. Similarly, when we look at a sunset, in spite of appearances, we do not feel compelled to believe that the sun is setting behind the Earth. We believe that the appearance of the sun setting is simply an illusion created by the rotation of the Earth. In each case, it is possible to give up a common-sense conviction because the hypothesis that replaces it both accounts for the experiences that led to that conviction in the first place, as well as explaining a whole lot of other facts that the common-sense view is unable to account for. Now, that's why we give up the belief in a flat Earth and literal sunsets in favor of the Copernican conception of the solar system. But we can't similarly give up the conviction of freedom because that conviction is built into every normal, conscious, intentional action. And indeed, we use this conviction in identifying and explaining actions. We can now draw the conclusions that are implicit in this discussion. First, if the worry about determinism is a worry that all of our behavior is in fact psychologically compulsive, then it appears that the worry is unwarranted. Insofar as psychological determinism is just an empirical hypothesis like any other, then the evidence we presently have available to us suggests it is false. So this does give us a modified form of compatibilism. It gives us the view that psychological libertarianism is compatible with physical determinism. Secondly, it even gives us a sense of could have in which people's behavior, though determined, is such that in that sense they could have done otherwise. The sense is simply that as far as the psychological factors were concerned, they could have done otherwise. The notions of ability, of what we're able to do and what we could have done, are often relative to some such set of criteria. For example, I could have voted for Carter in the 1980 American election, even if I didn't, but I could not have voted for George Washington. He was not a candidate. So there's a sense of could have in which there were a range of choices available to me, and in that sense, there were a lot of things I could have done, all other things being equal, which I did not, in fact, do. Now, similarly, because the psychological factors operating on me do not always, or even in general, compel me to behave in a particular fashion, I often, psychologically speaking, could have done something different from what I did, in fact, do. But third, this form of compatibilism still does not give us anything like the resolution of the conflict between freedom and determinism that our urge to radical libertarianism really demands. As long as we accept the bottom-up conception of physical explanation, and it's a conception on which the past 300 years of science is based, then psychological facts about ourselves, like any other higher-level facts, are entirely causally explicable in terms of, and entirely realized in systems of, elements at the fundamental microphysical level. Our conception of physical reality simply does not allow for radical freedom. Fourth and finally, for reasons that I don't really understand, evolution has given us a form of experience of voluntary action, where the experience of freedom, that is to say, the experience of the sense of alternative possibilities, is built into the very structure of conscious, voluntary, intentional human behavior. For that reason, I believe neither this discussion nor any other will ever convince us that our behavior is unfree. My aim in these lectures has been to try to characterize the relationships between the conception that we have of ourselves as rational, free, conscious, mindful agents with a conception that we have of the world as consisting of mindless, meaningless physical particles. It's tempting to think that just as we have discovered that large portions of common sense do not adequately represent how the world really works, so we might also discover that our conception of ourselves and our behavior is entirely false. But there are limits on this possibility. The distinction between reality and appearance cannot apply to the very existence of consciousness. For if it seems to me that I'm conscious, then I am conscious. We could discover all kinds of startling things about ourselves and our behavior, but we cannot discover that we do not have minds, that they do not contain conscious, subjective, intentionalistic mental states, nor could we discover that we do not at least try to engage in voluntary, intentional actions. The problem I've set myself is not to prove the existence of these things, but to examine their status and their implications for our conceptions of the rest of nature. My general theme has been that with certain important exceptions, our common sense conception of ourselves is perfectly consistent with our conception of nature as a physical system.
You've been listening to a podcast from the archives of the BBC Reith Lectures. For more podcasts, please visit bbc.co.uk/Radio 4.